In 1737, a French geographer named Philippe Buache published a map that would become one of the most perplexing enigmas in the history of cartography. This map depicted Antarctica not as the solid frozen continent we know today, but as an archipelago consisting of two separate landmasses divided by a waterway. What makes this extraordinary is not merely the artistic interpretation, but the fact that modern seismic surveys conducted in 1958, more than 2 centuries later, would confirm that beneath the miles of ice covering Antarctica, the continent is indeed composed of two major land masses separated by a deep channel. This revelation raises a question that has haunted researchers, historians, and mystery enthusiasts for decades. How could an 18th-century cartographer, working in an era when Antarctica had not yet been officially discovered, create a map showing geographical features that would remain hidden under ice until advanced 20th-century technology could penetrate the frozen depths? The implications of this question stretch far beyond mere cartographic curiosity. They touch upon the very foundations of our understanding of human history, ancient civilizations, and the technological capabilities of cultures that may have existed long before our recorded history begins. The Buache map was not created in isolation. Philippe Buache was a respected member of the French Royal Academy of Sciences and held the prestigious position of royal geographer to the King of France. He was not a fantasist or a charlatan, but a serious scholar working within the established scientific frameworks of his time. When he presented his map of Antarctica, he made a startling claim that has echoed through the centuries. Buache stated explicitly that his map was based on ancient source maps, documents of such antiquity that their origins were already lost to history by his own era. He did not claim to have surveyed Antarctica himself, nor did he suggest that any of his contemporaries had provided him with this information. Instead, he pointed to older maps, older knowledge, older sources that had somehow preserved information about a continent that would not be officially cited until 1820, when Russian explorers Fabian Gottlieb von Bellingshausen and Mikhail Lazarev became the first confirmed humans to lay eyes upon the frozen shores of Antarctica. This creates a temporal paradox that conventional historical narratives struggle to explain. If Buache copied his map from ancient sources, as he claimed, then who created those original maps? When were they created? And most importantly, how did the original cartographers know what Antarctica looked like beneath its ice? The precision of the Buache map becomes even more remarkable when we examine the specific details it contains. The two landmasses shown on his map are not vague approximations or artistic interpretations of what Antarctica might look like. They correspond with stunning accuracy to the actual subglacial topography of the continent as revealed by modern geophysical surveys. East Antarctica and West Antarctica are indeed two distinct geological entities, separated by the Transantarctic Mountains and a deep subglacial basin that would be filled with water if the ice sheet were removed. This basin runs roughly where Buache drew his dividing waterway. The eastern landmass on his map aligns with East Antarctica, which rests on a continental shield and rises well above sea level even when accounting for the weight of the ice. The western landmass corresponds to West Antarctica, which is actually an archipelago of islands whose bedrock lies below sea level, held together and elevated only by the massive ice sheets that bind them. Without the ice, West Antarctica would indeed appear as a collection of islands, just as ancient maps sometimes depicted it. The probability of Buache guessing this configuration by pure chance is astronomically small. The specific placement of the dividing channel, the relative sizes of the two landmasses, and the general outline of the continent all align too closely with reality to be dismissed as fortunate coincidence. To understand the full weight of this mystery, we must consider the timeline of Antarctic exploration and the history of human knowledge about this remote continent. In 1737, when Buache published his map, the very existence of Antarctica was still theoretical. Ancient Greek philosophers had hypothesized the existence of a great southern continent, which they called Terra Australis, based on the idea that there must be a landmass in the southern hemisphere to balance the known continents of the north. This was not based on exploration or observation, but on philosophical and geometric principles about the structure of the Earth. Throughout the medieval period and into the Renaissance, cartographers included Terra Australis on their maps, but these depictions were purely speculative, often showing a massive continent stretching across the entire bottom of the globe, far larger than Antarctica actually is. The first confirmed sighting of Antarctica would not occur until 1820, and even then, explorers could only see the coast. The interior remained completely unknown. It was not until the heroic age of Antarctic exploration in the early 20th century that expeditions began to venture inland, and even these brave explorers could only scratch the surface of the continent. They walked on ice, traveled across ice, and saw nothing but ice in every direction. What lay beneath that ice remained a complete mystery for another half-century. The breakthrough came during the International Geophysical Year of 1957 and 1958, when scientists from multiple nations coordinated the most comprehensive study of Antarctica ever attempted up to that time. Using seismic reflection techniques, radar soundings, and other geophysical methods, researchers began to map the bedrock topology beneath the Antarctic ice sheet. What they discovered astonished the scientific community. Antarctica was not a single unified continent, as had been assumed, but rather consisted of two distinct geological regions. East Antarctica proved to be a stable continental craton, a massive block of ancient rock that has remained relatively unchanged for hundreds of millions of years. West Antarctica, by contrast, was revealed to be a complex system of islands, peninsulas, and subglacial basins, many of which lie below sea level. The two regions are separated by the Transantarctic Mountains, one of the longest mountain ranges on Earth, and by deep channels that would allow seawater to flow between them if the overlying ice were removed. This configuration matched the Buache map with uncanny precision. Here was a map created in 1737, showing Antarctica as two landmasses separated by a waterway, and here was scientific data from 1958, confirming that this depiction was essentially correct. The question that immediately arose was simple yet profound: how did Buache know? The conventional explanation offered by mainstream historians is that Buache made an educated guess based on the cartographic conventions of his time and got lucky. They point out that many 18th-century maps showed hypothetical continents in regions that had not yet been explored, and that occasionally these speculative maps bore some resemblance to reality. They argue that Buache may have been influenced by earlier maps that showed Antarctica or Terra Australis as divided or fragmented, and that he simply continued this tradition. However, this explanation fails to account for the specific accuracy of his depiction. Buache did not show Antarctica as vaguely divided or roughly separated. He showed it with a level of detail that corresponds remarkably well to the actual subglacial geography. The placement of the dividing waterway, the proportions of the two landmasses, and the general configuration all match modern data too closely to be dismissed as mere guesswork. Moreover, Buache himself stated that he was working from older source maps. He did not claim to be inventing or imagining Antarctica's geography. He claimed to be copying it from ancient documents. This raises the question, if we take Buache at his word, what were these source maps, and where did they come from? This question becomes even more intriguing when we consider that the Buache map is not unique. It is part of a broader collection of ancient and medieval maps that show Antarctica, or regions that appear to be Antarctica, with surprising accuracy. The most famous of these is the Piri Reis map of 1513, created by the Ottoman admiral and cartographer Piri Reis. This map shows the coastlines of South America and Africa with remarkable precision, but it also includes a southern landmass that some researchers believe represents the coast of Antarctica. What makes this particularly interesting is that the coastline shown on the Piri Reis map appears to depict an ice-free Antarctica, showing details of bays, rivers, and coastal features that are currently buried under miles of ice. Piri Reis himself wrote notes on his map explaining that he had compiled it from approximately 20 older source maps, some of which dated back to the time of Alexander the Great. Another example is the Orontius Phineas map of 1531, which shows Antarctica as a distinct continent at the South Pole, complete with mountain ranges, rivers, and coastal details. Like the Buache map, the Orontius Phineas map shows Antarctica without ice coverage, depicting geographical features that would not be known to modern science until the 20th century. These maps suggest the existence of a cartographic tradition, a body of geographical knowledge that was passed down through the centuries, possibly originating from a time when Antarctica was not covered in ice or when some unknown civilization had the technology to map it despite the ice. The geological history of Antarctica adds another layer to this mystery. Scientific evidence tells us that Antarctica has been covered in ice for approximately 34 million years, since the Eocene-Oligocene boundary when global temperatures dropped and the Antarctic ice sheet began to form. Before this time, Antarctica was a very different place. During the Cretaceous period, roughly 100 million years ago, Antarctica was covered in forests and was home to dinosaurs. Even during the early Cenozoic era, before the ice sheets formed, Antarctica had a temperate climate with forests and wildlife. However, all of this occurred millions of years before modern humans evolved. Homo sapiens, our species, only emerged approximately 300,000 years ago, and even if we extend our consideration to earlier hominids, we are still looking at only a few million years of human or proto-human existence. This creates a chronological impossibility if Antarctica has been frozen for 34 million years, and if humans have only existed for a few 100,000 years, then how could any human civilization have mapped Antarctica when it was ice-free? The conventional timeline simply does not allow for this possibility. Yet the maps exist, and their accuracy demands explanation. Some researchers have proposed that there may have been brief warm periods during the more recent past when parts of Antarctica were temporarily ice-free. There is some geological evidence for climate fluctuations during the Pliocene epoch, roughly 3 to 5 million years ago, when global temperatures were warmer than today and parts of Antarctica may have had less ice coverage. However, this still predates the evolution of modern humans by millions of years. Another hypothesis suggests that there may have been a more recent warm period, perhaps during the medieval warm period or even earlier, when some coastal regions of Antarctica were accessible. However, the evidence for such a recent warming sufficient to expose significant portions of Antarctica's coastline is lacking. Ice core data and geological studies consistently show that Antarctica has maintained its ice sheet throughout the entire period of human civilization as we currently understand it. This leaves us with three possible explanations, each of which challenges our conventional understanding in different ways. First, the maps could be elaborate hoaxes or fabrications, but this seems unlikely given the historical documentation surrounding them and the reputations of the cartographers who created them. Second, the apparent accuracy of the maps could be coincidental, the result of artistic interpretation and lucky guesses, but the probability of this diminishes with each new correlation between ancient maps and modern geographical data. Third, and most controversially, there may have been an advanced civilization in the ancient past, a culture with sophisticated maritime and cartographic capabilities that explored and mapped Antarctica before the historical record as we know it begins. This third possibility, while speculative, is the one that has generated the most interest and debate among alternative historians and researchers who question conventional historical narratives. The theory suggests that there may have been a global maritime civilization during the late Ice Age, perhaps between 15,000 and 10,000 years ago, which possessed advanced navigational technology and created detailed maps of the world, including Antarctica. According to this hypothesis, these maps were preserved through the centuries, copied and recopied by successive civilizations, though their origins were forgotten or became obscured by myth and legend. As these maps passed through different cultures and time periods, some of their accuracy may have been lost through repeated copying, but core geographical information remained intact. By the medieval period, cartographers like Pierre Race had access to collections of these ancient maps in libraries and archives, particularly in major cultural centers like Constantinople, Alexandria, and later in European royal libraries. They incorporated information from these old maps into their own work, sometimes without fully understanding the source or significance of what they were copying. This would explain why medieval and Renaissance maps sometimes show geographical features with accuracy that seems impossible for their time period. They were not discovering this information themselves, but rather preserving knowledge from a much earlier source. The question of what happened to this hypothetical ancient civilization and why no other clear traces of it survive is a significant challenge to this theory. Proponents argue that a civilization existing during the late Ice Age would have been concentrated along coastal areas, which were submerged when sea levels rose at the end of the Ice Age, potentially destroying or burying most archaeological evidence. They point to recent discoveries of submerged settlements off the coasts of various continents as evidence that sophisticated human societies existed in areas that are now underwater. They also note that absence of evidence is not necessarily evidence of absence, particularly when we consider how much of the Earth's surface remains unexplored or understudied. Critics counter that the level of technological sophistication required to conduct the kind of systematic mapping shown on these ancient maps would have left other traces, such as advanced tools, writings, or architectural remains, and that the complete absence of such evidence makes the existence of this civilization highly improbable. This debate remains unresolved, with passionate advocates on both sides presenting their arguments and evidence. What makes the Buache map particularly significant in this debate is its precision and its provenance. Unlike some other controversial maps, the Buache map comes from a known, respected cartographer working within the established scientific institutions of his time. There is no question about its authenticity as an 18th-century document. The question is solely about the accuracy of its depiction and the sources Buache used. When we examine the map in detail, we find that it shows not just a general division of Antarctica, but specific geographical features that align with modern knowledge. The relative sizes of the two landmasses, the location of the dividing channel, and the overall configuration of the continent all match seismic data with remarkable fidelity. This is not a vague or ambiguous correlation that requires generous interpretation. It is a clear, specific match that demands explanation. Buache himself provided an explanation. He copied the map from older sources. If we accept his word, then we must ask where those older sources obtained their information. Each step backward in time makes the mystery deeper. Who made the original maps? When were they made? What technology did they use? How did they explore Antarctica? And perhaps most intriguingly, why did this knowledge become lost, only to be partially recovered centuries later through scattered copies and fragments? The waterway that Buache showed dividing Antarctica is particularly interesting when we consider modern geological understanding. The Transantarctic Mountains, which form the boundary between East and West Antarctica, are one of the world's longest mountain ranges, stretching more than 3,500 kilometers across the continent. However, these mountains are not a continuous barrier. They are intersected by several deep channels and basins, some of which extend below sea level. If the Antarctic ice sheet were to melt completely, a process that would take thousands of years even under extreme warming scenarios, these channels would fill with seawater, effectively separating East and West Antarctica. The configuration would look remarkably similar to what Buache drew in 1737. Some of these channels are extremely deep. The Bentley Subglacial Trench in West Antarctica reaches depths of more than 2,500 meters below sea level, making it one of the lowest points on Earth not covered by ocean water. The only reason it is not filled with seawater currently is the enormous weight and volume of the ice sheet above it. This geological structure, which was completely unknown in Buache's time and would remain unknown for more than 200 years after his map was published, is depicted on his map with startling accuracy. We must also consider the broader context of 18th-century geographical knowledge and cartographic practice. In Buache's time, the Southern Ocean was one of the last great blank spaces on the map. European explorers had sailed through southern waters, and some had even caught glimpses of ice and land far to the south, but systematic exploration of Antarctica was still decades away. Captain James Cook would not make his famous circumnavigation of Antarctica until the 1770s, several decades after Buache's map was published. Cook sailed farther south than any previous explorer, crossing the Antarctic Circle multiple times, but he never actually sighted the Antarctic continent itself. He encountered only ice fields and icebergs, which convinced him that if land existed in these latitudes, it was permanently locked in ice and uninhabitable. Cook's reports actually discouraged further exploration of Antarctica for several decades, as his descriptions of endless ice and brutal conditions made the region seem both unreachable and worthless. It was not until the 1820s that explorers confirmed the existence of an Antarctic continent, and even then, decades more would pass before the extent and nature of the landmass became clear. Yet here was Buache, working in 1737, before any of this exploration had occurred, creating a map that showed not just the existence of Antarctica but its fundamental geological structure. The mystery deepens when we examine Buache's own writings and explanations about his map. He was quite clear that he was not claiming to have discovered or invented this information. In the notes accompanying his map, he explained that he had consulted older charts and geographical texts in creating his depiction of the southern continent. He was working within a long cartographic tradition that included speculative maps of Terra Australis, but his map was notably different from most such speculations. Where many earlier maps showed Terra Australis as a massive continent extending across much of the southern hemisphere, Buache's map showed a smaller, more accurately proportioned landmass. Where earlier maps often depicted terra australis with elaborate illustrations of imagined geography, complete with invented place names and fictional features, Buache's map was more restrained and focused on what he considered to be reliable information from his sources. This suggests that he had access to source material that was different from or more detailed than the typical speculative maps of his era. What that source material was, and where it ultimately originated, remains one of the great unsolved questions of historical cartography. To truly understand the significance of Philippe Buache's mysterious map, we must first understand the man himself and the intellectual world in which he operated. Philippe Buache was born in Paris in 1700, at the dawn of the Age of Enlightenment, a period when European science and scholarship were undergoing profound transformations. He came of age during a time when geography was transitioning from a field dominated by classical texts and speculative philosophy to one increasingly grounded in empirical observation and mathematical precision. Buache entered this world through an apprenticeship with Guillaume Delisle, one of the most respected cartographers of the early 18th century. Delisle was known for his rigorous approach to mapmaking, insisting on verifying sources and rejecting the fantastic embellishments that had characterized many earlier maps. Under Delisle's tutelage, Buache learned not only the technical skills of cartography but also the scholarly discipline of evaluating and comparing multiple sources to arrive at the most accurate possible representation of geographical reality. This training would shape Buache's entire career and makes his later claims about ancient source maps all the more significant, because this was not a man prone to flights of fancy or uncritical acceptance of dubious information. When Delisle died in 1726, Buache married his daughter and inherited both his workshop and his position as one of France's leading geographers. This was not merely a professional advancement but a recognition of Buache's scholarly credentials and his standing in the scientific community. In 1729, he was elected to the Royal Academy of Sciences, one of the most prestigious scientific institutions in Europe. The Academy was highly selective, admitting only scholars who had made significant contributions to their fields. Membership required the approval of existing members and was considered the highest honor a French scientist could receive. Buache's election at the relatively young age of 29 demonstrated that his peers recognized him as a serious and capable scholar. Throughout the 1730s and 1740s, he continued to build his reputation through publications on various aspects of physical geography, including theories about mountain ranges, river systems, and the structure of continents. He was particularly interested in what he called the framework of the Earth, the underlying patterns and structures that gave shape to the continents and oceans. This theoretical interest in the fundamental structure of the planet would later inform his approach to mapping Antarctica. In 1737, the same year he published his Antarctic map, Buache also presented to the Academy his theory of oceanic basins and submarine mountain ranges. He proposed that the ocean floors were not flat and featureless, as many assumed, but contained mountain ranges, valleys, and basins much like those on land. This was a radical idea for its time, as no one had yet been able to systematically map the ocean floor. Buache developed this theory through careful analysis of islands, which he correctly understood to be the peaks of submarine mountains. He studied the distribution of islands in various ocean regions and used this data to infer the existence of underwater mountain chains. His theory was initially met with skepticism by some of his colleagues, but it would be vindicated in the 19th and 20th centuries when improved sounding techniques revealed that Buache had been essentially correct. The ocean floors do indeed contain mountain ranges and other topographical features. This episode demonstrates several important aspects of Buache's intellectual character. First, he was capable of theoretical thinking that went beyond the immediately observable, extrapolating from limited data to develop broader models of geographical reality. Second, he was willing to propose controversial ideas if he believed the evidence supported them. Third, and most importantly for our purposes, his theoretical predictions about unobserved geographical features proved to be accurate when later technology allowed them to be tested. This established pattern makes his claims about Antarctica all the more intriguing. If he was capable of correctly inferring the structure of ocean floors from limited evidence, might he also have had access to information about Antarctica that allowed him to accurately depict its structure? The year 1737 was particularly significant in Buache's career because it marked his formal appointment as Premier Géographie du Roi, or First Geographer to the King. This was the highest position a cartographer could hold in France, carrying both prestige and practical authority. As royal geographer, Buache had access to the Crown's extensive collections of maps and geographical documents, many of which were not available to other scholars. The French Royal Library contained materials gathered from around the world, including maps and charts seized from other nations during wars, documents purchased from private collectors, and materials donated by explorers and diplomats. Some of these documents dated back centuries. The library included medieval Arabic maps, Renaissance Portuguese and Spanish charts from the Age of Exploration, and various other materials that might have contained geographical information unavailable elsewhere. When Buache claimed that his Antarctic map was based on ancient sources, he was speaking as someone who had access to one of the most comprehensive collections of geographical documents in Europe. He would have been familiar with materials that most other scholars never saw. This lends credibility to his claims about consulting older maps, even if the specific sources he used have since been lost or remain unidentified. It is important to understand that in the 18th century, the distinction between ancient and modern geographical knowledge was not as clear-cut as we might assume today. Medieval and Renaissance scholars recognized that ancient civilizations, particularly the Greeks and Romans, had possessed considerable geographical knowledge, much of which had been lost during the medieval period and was only gradually being recovered through the rediscovery of classical texts. The works of Ptolemy, the great Greco-Roman geographer of the 2nd century AD, had been lost to Western Europe during the Middle Ages but were reintroduced through Arabic translations and Byzantine manuscripts in the 14th and 15th centuries. When Renaissance scholars examined Ptolemy's geography, they found that it contained information about distant regions that had been forgotten in Europe. Ptolemy's maps of Africa and Asia were in some respects more accurate than medieval European maps of the same regions. This demonstrated that ancient knowledge could sometimes surpass more recent understanding, and it created a scholarly culture in which cartographers routinely consulted old texts and maps alongside contemporary sources. Buache would have been working within this tradition. When he claimed to be using ancient sources, he was following an accepted scholarly practice, not making an unusual or suspicious claim. However, the specific claim that ancient sources contained accurate information about Antarctica was far more controversial than claims about other regions. For most of the known world, scholars could verify ancient geographical claims through contemporary exploration. If an ancient text described a river in Africa or a mountain range in Asia, 18th-century explorers could visit those locations and confirm or refute the ancient descriptions. Antarctica presented a unique problem because it remained inaccessible. There was no way for Buache or his contemporaries to verify the accuracy of any claims about Antarctic geography through direct observation. This meant that his Antarctic map existed in a kind of epistemological limbo. It could not be confirmed, but neither could it be definitively disproven. Some of Buache's colleagues likely dismissed the map as speculative, while others may have been intrigued by his claims about ancient sources but uncertain how to evaluate them. The map remained a curiosity, interesting but unverifiable, for more than 2 centuries. Only when 20th-century technology finally allowed scientists to map the bedrock beneath Antarctica's ice sheet did it become possible to assess the accuracy of Buache's depiction. The fact that his map proved to be remarkably accurate was not something that could have been anticipated or explained by the scholarly standards of his own time. The question of what specific sources Buache consulted has been the subject of considerable speculation and research. Unfortunately, Buache did not provide detailed citations or bibliographic references in the manner that modern scholars would expect. This was not unusual for his time, when scholarly citation practices were less rigorous and standardized than they are today. Cartographers typically did not provide exhaustive lists of their sources, particularly when those sources were maps and charts rather than written texts. Nevertheless, we can make some educated inferences about the kinds of materials Buache might have consulted based on what we know about the collections available to him and the broader traditions of Renaissance and early modern cartography. One likely category of sources would have been Portuguese and Spanish charts from the Age of Exploration. During the 15th and 16th centuries, Portuguese and Spanish explorers had systematically mapped the coasts of Africa, Asia, and the Americas, creating detailed nautical charts that were closely guarded state secrets. These charts were considered strategically valuable, as they gave Portugal and Spain advantages in navigation and trade. However, over time, copies of these charts circulated more widely, and some made their way into the collections of other European powers. The French Royal Library likely contained copies of Portuguese and Spanish charts, either obtained through diplomatic channels, purchased from collectors, or captured during conflicts between France and the Iberian powers. Some researchers have suggested that Portuguese explorers may have ventured farther south than official records indicate, possibly even sighting Antarctica or its surrounding ice fields during the early 16th century. While there is no definitive proof of this, there are suggestive hints in various documents and maps from this period. The Piri Reis map of 1513, created by the Ottoman admiral, included notes indicating that he had consulted Portuguese sources, and the southern landmass on his map has been interpreted by some as a depiction of Antarctica. If Portuguese explorers had indeed gathered information about southern regions, whether through direct observation or from even earlier sources, this information might have been incorporated into charts that eventually made their way to France. Another possible category of sources would have been medieval Arabic maps and geographical texts. During the medieval period, Arab scholars had preserved and expanded upon Greek and Roman geographical knowledge, creating sophisticated maps and descriptions of the known world. Some of these Arabic texts contained information that was not available in European sources, including descriptions of distant lands and seas. When Europeans began to study Arabic geographical works during the Renaissance, they sometimes found information that challenged or supplemented their own understanding. Buache, with his access to the Royal Library, would have had opportunities to consult such materials, and he might have found references to southern lands that informed his Antarctic map. There is also the intriguing possibility that Buache had access to maps or texts that have since been lost. The history of cartography is full of examples of important documents that once existed but no longer survive. Libraries have burned, collections have been scattered during wars, and individual items have been lost or destroyed through accident or neglect. The Library of Alexandria, perhaps the most famous example, contained countless ancient texts that were lost when the library was destroyed. But this pattern of loss has continued throughout history. Many medieval and Renaissance manuscripts exist only in fragmentary form or are known only through references in other texts. It is entirely possible that Buache consulted maps or geographical texts that were available in the 18th century but have since disappeared. If these lost sources contained accurate information about Antarctica, their disappearance would explain why we cannot now verify Buache's claims about his sources. This is frustrating for modern researchers, but it is a reality we must accept when dealing with historical materials. Absence of evidence, particularly evidence of documents that may have existed centuries ago, cannot be taken as proof that those documents never existed. The intellectual context of the 18th century also included a fascination with ancient wisdom and lost knowledge. The Enlightenment, despite its emphasis on reason and empirical observation, coexisted with a romantic interest in ancient civilizations and the idea that earlier cultures might have possessed knowledge that had been forgotten. This was not mere fantasy or mysticism. Scholars had concrete examples of ancient knowledge that had been lost and later recovered. The rediscovery of Ptolemy's geography, as mentioned earlier, was one such example. The recovery of classical mathematical and scientific texts was another. This created a cultural atmosphere in which claims about ancient geographical knowledge were taken seriously, at least as possibilities worth investigating. Buache's claims about ancient sources for his Antarctic map would have resonated with this intellectual culture. His colleagues at the Royal Academy would not have dismissed such claims out of hand, even if they remained skeptical about the specific details. The possibility that ancient civilizations had explored and mapped distant regions was considered plausible, though difficult to prove. We must also consider Buache's theoretical framework for understanding the structure of continents and oceans. He believed that the Earth's surface was organized according to underlying structural principles, what he called the skeleton or framework of the planet. He thought that mountain ranges formed interconnected systems that extended across continents and even beneath the oceans. His theory of submarine mountain ranges was part of this broader understanding. When he approached the problem of Antarctica, he would have brought this theoretical perspective to bear on whatever sources he consulted. If ancient maps showed Antarctica as divided into two landmasses, this would have fit well with his ideas about how continents were structured. He might have found the division plausible because it matched his theoretical expectations about continental geography. This raises an interesting question about the relationship between theory and observation in Buache's work. Was his Antarctic map purely based on ancient sources, or did he modify or interpret those sources through the lens of his own theories? We cannot know for certain, but it seems likely that some combination of both factors was at work. Buache was not simply copying old maps mechanically. He was a sophisticated scholar who evaluated his sources critically and interpreted them according to his understanding of geographical principles. The timing of Buache's map is also significant in relation to broader developments in Antarctic exploration and geographical theory. The 1730s were a period of increasing European interest in the southern oceans and the possibility of a great southern continent. While Antarctica itself had not yet been discovered, explorers were pushing farther south in search of new lands. The Dutch explorer Abel Tasman had discovered Tasmania and New Zealand in the 1640s, proving that there were significant landmasses in the southern hemisphere. The Spanish explorer Álvaro de Mendana had discovered the Solomon Islands in the 1560s, and various other Pacific islands had been found by European navigators. These discoveries fueled speculation about what else might exist in the vast unexplored regions of the southern seas. Philosophers and geographers debated whether there must be a large southern continent to balance the landmasses of the northern hemisphere. This idea, rooted in ancient Greek philosophy, held that the Earth must be symmetrically arranged, with comparable amounts of land in both hemispheres. While this was not correct in a literal sense, as the southern hemisphere does contain less land than the northern, the basic intuition that there should be significant southern landmasses proved to be true. Buache's map appeared in this context of speculation and debate about the southern continent. However, his map was notable for its specificity and detail compared to most contemporary speculations, which tended to be vague or wildly inaccurate. It is worth examining in detail what Buache's map actually showed and how it compared to other contemporary maps of the supposed southern continent. Many 18th-century maps depicted Terra Australis as an enormous landmass, far larger than Australia or even Antarctica, stretching across the entire bottom of the globe from southern Africa to South America. These maps often showed Terra Australis with elaborate coastlines, bays, and even labeled regions, all completely invented. The cartographers who created these maps were filling in blank spaces on their maps with educated guesses and artistic flourishes. Buache's Antarctic map was fundamentally different. It showed a relatively modest-sized continent in the polar region, not an enormous landmass stretching across lower latitudes. The proportions were reasonably accurate, with Antarctica shown as comparable in size to Australia, which is close to the truth. Most strikingly, Buache showed Antarctica as divided into two distinct landmasses with a waterway between them. This was not a common feature of speculative maps of Terra Australis. Most such maps showed the southern continent as a single unified landmass. Where did Buache get this specific idea of a divided continent? If he was simply guessing or engaging in philosophical speculation about balance and symmetry, why would he choose to divide the continent? A unified landmass would seem more in keeping with classical ideas about continental structure. The divided configuration suggests that Buache was working from some source that specifically indicated this division. The two landmasses on Buache's map are shown with different characteristics, another detail that increases the map's plausibility. The eastern landmass is depicted as larger and more substantial, while the western landmass is shown as somewhat smaller and more complex in outline. This corresponds well with the actual situation, where East Antarctica is a large stable continental block and West Antarctica is a more complex system of islands and peninsulas. Did Buache's sources somehow indicate this distinction? Or did he infer it from theoretical principles? Again, we cannot know for certain, but the accuracy of the distinction is noteworthy. If Buache had simply been dividing a hypothetical continent arbitrarily, we would not expect the two portions to have characteristics that match the actual differences between East and West Antarctica. The probability of this occurring by chance is quite low. This brings us back to the central question: how did Buache know? Even if we grant that he had access to ancient sources, we must still ask how those sources acquired their information. This question leads us into more speculative territory, but it is a question that must be addressed if we are to make sense of the Buache map and similar cartographic anomalies. One possibility, though admittedly the most conservative explanation, is that the accuracy of Buache's map is less remarkable than it initially appears. Skeptics might argue that any map showing Antarctica as divided into two parts would have a significant probability of matching reality simply because there are only so many ways to divide a continent. If we accept this argument, then Buache's map would be an interesting coincidence but not a genuine mystery. However, this explanation seems inadequate when we consider the specific details of the match between Buache's map and modern seismic data. The division is not placed arbitrarily. It runs approximately where the actual division between East and West Antarctica occurs. The proportions of the two landmasses are reasonably accurate. The general outline of the continent, while simplified, captures the essential shape of Antarctica. These multiple points of correspondence reduce the likelihood that we are dealing with pure coincidence. To illustrate this point, we can imagine what would happen if we asked 100 people to draw a map of an imaginary continent divided into two parts. Some of these drawings would, by chance, have features that resembled real geographical formation somewhere on Earth. But the probability that one of these random drawings would match a specific real location in multiple specific ways is much lower. Buache's map does not just vaguely resemble Antarctica. It resembles Antarctica in several specific, testable ways. Another more radical possibility is that the ancient sources Buache consulted were themselves based on direct observation of Antarctica during a period when it was more accessible than it is today. This would require either that Antarctica was less ice-covered at some point during the period of human civilization, or that some ancient culture had the technology to explore and map Antarctica despite its ice coverage. Both of these scenarios face significant challenges from mainstream science. As mentioned earlier, geological evidence indicates that Antarctica has been substantially ice-covered for millions of years, far longer than human civilization has existed. However, some researchers have pointed to evidence of climate fluctuations during more recent periods that might have affected Antarctica's ice coverage. The medieval warm period, which lasted from roughly 950 to 1250 AD, was a time of warmer global temperatures when ice coverage in the Arctic and other regions was reduced. Some have speculated that Antarctica might also have experienced reduced ice coverage during this period, though evidence for this is limited. An even more dramatic warm period occurred during the early Holocene, roughly 9,000 to 11,000 years ago, following the end of the last ice age. Global sea levels rose significantly during this period as ice sheets melted, and climate patterns were different from those of today. Could Antarctica have been more accessible during this time? The mainstream scientific consensus is that Antarctica's ice sheet remained largely intact even during these warm periods, but some researchers argue that more localized melting might have occurred, particularly along coastal regions. If we entertain the possibility that some ancient culture explored Antarctica during a period of reduced ice coverage, we must ask who this culture might have been and how they could have accomplished such a feat. The exploration and mapping of Antarctica would have required sophisticated maritime technology, including seaworthy vessels capable of navigating the treacherous southern oceans, navigation instruments for determining position far from land, and the organizational capacity to mount and sustain long-distance expeditions. By conventional understanding, no culture before the modern era possessed all of these capabilities at a sufficient level to explore Antarctica systematically. The Polynesians, who were perhaps the most accomplished ocean voyagers of the pre-modern world, spread across the Pacific and reached islands as distant as Easter Island and Hawaii, demonstrating remarkable navigational skills. However, there is no evidence that they ventured as far south as Antarctica, and the climate and sea conditions of the Antarctic region would have presented challenges far beyond those of the Pacific Islands. The Vikings, another seafaring culture, explored the North Atlantic extensively and established settlements in Iceland, Greenland, and briefly in North America. But again, there is no evidence of Viking exploration of southern regions, and their ship technology was optimized for North Atlantic conditions, not for the Southern Ocean. This brings us to one of the most controversial hypotheses in the entire discussion of ancient maps, the possibility of a lost advanced civilization. Some researchers have proposed that there existed, during the late Ice Age or early Holocene period, a sophisticated maritime civilization that explored the world extensively and created accurate maps, but which was destroyed or dispersed by catastrophic events, leaving few traces. According to this hypothesis, the survivors of this civilization or the cultures they influenced preserved some of their geographical knowledge through oral tradition and fragmentary maps, which were eventually incorporated into the cartographic traditions of later civilizations. This knowledge, though degraded and partially lost over millennia, retained enough accuracy to inform maps like those of Piri Reis, Orontius Phineus, and Philippe Buache. This hypothesis faces obvious objections from mainstream archaeology and history. Where is the physical evidence of such a civilization? Why have no clear archaeological sites been discovered? How could an advanced culture disappear so completely? Proponents of the lost civilization hypothesis offer several responses to these objections. They point out that if such a civilization existed during the late Ice Age, its settlements would likely have been concentrated along coastlines that are now submerged due to post-Ice Age sea level rise. Archaeological evidence from such settlements would be underwater, and underwater archaeology is a relatively young field that has explored only a tiny fraction of the continental shelves where such evidence might exist. They also note that several puzzling archaeological sites around the world, such as Göbekli Tepe in Turkey and certain megalithic structures in other regions, suggest that some prehistoric cultures were more sophisticated than traditional models would predict. The debate over these ideas is far from settled, and mainstream academia remains highly skeptical of claims about lost advanced civilizations. Most archaeologists and historians argue that the evidence can be explained without resorting to such extraordinary hypotheses. The accuracy of ancient maps can be explained as a combination of skilled observation, accumulated knowledge from various sources, some lucky guesses, and the selective preservation of accurate information while inaccurate information was discarded or corrected. According to this view, there is no need to postulate a lost civilization. Maritime knowledge gradually accumulated over centuries and millennia as various cultures explored coastlines and shared information through trade and cultural contact. Maps improved incrementally as cartographers compiled information from multiple sources and corrected errors. Occasionally, ancient maps would preserve accurate information that was later forgotten, creating the appearance of mysterious ancient knowledge when in fact it was simply good observation that happened to be preserved. This explanation is more parsimonious than the lost civilization hypothesis, requiring fewer extraordinary assumptions. However, it still leaves certain specific puzzles, like the Buache map, somewhat inadequately explained. How exactly would incremental maritime exploration have produced accurate knowledge of Antarctica's subglacial structure? What mechanism would have preserved this specific piece of information through centuries of map copying while other information was lost or distorted? The physical characteristics of the Buache map itself warrant careful examination, as the details of its presentation reveal much about how Buache understood and interpreted his sources. The map is rendered in the formal cartographic style of 18th-century French geography, with precise latitude and longitude lines creating a grid across the polar projection. Antarctica is shown centered at the South Pole, with the continent divided by what Buache labeled as a sea or channel running roughly east to west. The two landmasses are labeled with Latin terms, reflecting the scholarly conventions of the period. The eastern portion, corresponding to what we now call East Antarctica, is designated as the larger and more prominent of the two land areas. The western portion, matching modern West Antarctica, is shown as somewhat smaller and with a more irregular coastline. What is particularly striking is that Buache did not embellish his map with the kind of decorative elements that were common in 18th-century cartography. There are no sea monsters, no elaborate cartouches, no illustrations of indigenous peoples or wildlife. The map is austere and functional, suggesting that Buache wanted it to be taken seriously as a scientific document rather than as an artistic interpretation or philosophical speculation. This restraint is significant because it indicates that Buache believed he was presenting factual geographical information, not engaging in imaginative world-building. The scale and proportions of the Buache map also merit attention. When we compare the size of Antarctica as shown on his map to the sizes of other continents, we find that Buache rendered it at approximately the correct relative size. Antarctica is shown as smaller than Africa or Asia but comparable to Australia, which is accurate. Many speculative maps of Terra Australis from this period showed the southern continent as enormous, sometimes larger than all other continents combined. This exaggeration reflected the philosophical belief that there must be vast southern landmasses to balance the known land of the northern hemisphere. Buache, however, departed from this tradition. His Antarctica is proportioned realistically, another detail that suggests he was working from information rather than from philosophical speculation. The outline of the continent, while simplified compared to modern maps, captures the general shape reasonably well. The Antarctic Peninsula, which extends northward towards South America, is indicated on Buache's map in approximately the correct position. The overall circular form of the continent is preserved, with appropriate indentation suggesting bays or coastal irregularities. These are not dramatic or fanciful features but subtle variations that give the coastline a naturalistic appearance, the kind of variation that would result from actual surveying rather than from theoretical construction. The most critical feature of the Buache map, of course, is the channel dividing the continent. This channel is shown running from what would be the Weddell Sea region on one side to the Ross Sea region on the other, approximately bisecting the continent. Modern seismic surveys have revealed that beneath the ice, there is indeed a deep subglacial basin running roughly along this line. The Transantarctic Mountains form a boundary between East and West Antarctica, but they are not a complete barrier. They are intersected by several deep channels and trenches, some of which would become waterways if the ice sheet were removed. The most significant of these is the West Antarctic Rift System, a geological feature that has created a zone of crustal thinning and subsidence. This rift system has lowered much of West Antarctica below sea level, creating a situation where, without ice, much of West Antarctica would be submerged or would consist of islands separated by channels of water. Buache's dividing waterway corresponds reasonably well to this rift system and the associated subglacial basins. The correlation is not perfect, as Buache showed a relatively simple channel while the actual subglacial topography is more complex, but the basic concept of a division in this general location is correct. This raises the question of whether Buache's sources somehow indicated the existence of this geological feature or whether the correspondence is coincidental. To understand how remarkable this correspondence is, we need to consider what Antarctica would actually look like without its ice sheet. Scientists have created detailed maps of Antarctic bedrock topography using data from radar surveys, seismic studies, and satellite gravity measurements. These maps reveal a continent that is quite different from its ice-covered appearance. East Antarctica, as Buache's map suggests, would remain a substantial landmass rising well above sea level. It sits on a stable continental craton, a thick piece of ancient crust that has remained geologically stable for hundreds of millions of years. Even without ice, East Antarctica would be a large continent with mountains, valleys, and plateaus, though its surface is currently depressed by the weight of the ice sheet and would rebound slowly if that weight were removed. West Antarctica presents a very different picture. Without ice, much of West Antarctica would be underwater. What would remain above water would be a collection of mountainous islands and peninsulas, an archipelago rather than a unified continent. The Antarctic Peninsula would remain, as would several mountainous regions, but vast areas would be flooded. The channels between these islands would in some cases be quite deep, in other cases relatively shallow. The overall effect would be of a fragmented landmass, just as Buache's map suggests. The division between these two very different geological provinces occurs roughly along the line that Buache drew as his waterway. The geological reasons for this division are complex and relate to the different formation histories of East and West Antarctica. East Antarctica is part of the ancient supercontinent Gondwana, which began to break apart about 180 million years ago. When Gondwana fragmented, East Antarctica remained as a stable continental core while other pieces, including Africa, South America, India, and Australia, drifted away. East Antarctica thus preserves ancient rocks dating back more than 3 billion years in some areas, making it one of the oldest pieces of continental crust on Earth. West Antarctica, by contrast, is a much younger and more complex geological assemblage. It was formed through the collision and accretion of several smaller crustal blocks and volcanic island arcs during the Mesozoic and Cenozoic eras. This process of formation left West Antarctica with a more fragmented structure and thinner crust than East Antarctica. The West Antarctic Rift System, which began to form about 105 million years ago and is still geologically active, has further weakened and thinned the crust in this region. This rifting has created the low-lying topography that characterizes much of West Antarctica. The fact that Buache's map shows a fundamental division between two different types of Antarctic terrain, corresponding to this real geological boundary, is difficult to explain as coincidence. How would an 18th-century cartographer, working without any knowledge of plate tectonics or crustal structure, arrive at a configuration that matches the actual geological organization of Antarctica? One possible answer lies in considering what ancient explorers might have been able to observe if they had visited Antarctica during a period of reduced ice coverage. Even if Antarctica was not completely ice-free, a significant reduction in ice extent would have revealed enough of the underlying topography to make the division between East and West Antarctica apparent. Suppose that during some warmer period in the past, the ice sheets covering Antarctica were substantially smaller than they are today. The higher elevations of East Antarctica would have remained ice-covered, but lower-lying coastal areas might have been exposed. In West Antarctica, where much of the bedrock lies below sea level, a reduction in ice would have been particularly dramatic. Areas that are now buried under kilometers of ice would have been covered instead by shallow seas or would have appeared as islands. The channels and straits between these islands would have been navigable, revealing the fragmented nature of West Antarctic geography. An explorer sailing along the Antarctic coast during such a period would have been able to observe directly that the continent consisted of two distinct regions, a large, solid landmass to the east and a more broken, island-studded region to the west. This observation could have been recorded on maps, which were then copied and recopied through the centuries, eventually reaching Buache sources. This scenario requires that Antarctica experienced a significant warm period during the time of human civilization, a possibility that remains controversial but not entirely impossible. The climate history of Antarctica is still being worked out in detail by glaciologists and paleoclimatologists. Ice core records provide detailed information about past temperatures and atmospheric conditions going back hundreds of thousands of years. These records show that Antarctica has experienced numerous climate fluctuations, though the continent has remained largely ice-covered throughout this period. However, ice cores can only tell us about the ice itself, not about what lies beneath it. Other types of geological evidence, such as sediment cores from the ocean floor around Antarctica and studies of glacial deposits on the continent, provide additional information about past ice extent. Some of this evidence suggests that Antarctica's ice sheets have varied in size over time, growing during cold periods and shrinking during warm periods. The most recent period of significant ice sheet reduction occurred during the early Holocene, roughly 11,000 to 8,000 years ago, when global temperatures were warmer than they are today. During this period, sea levels were rising rapidly as ice sheets in the northern hemisphere melted, and there is some evidence that Antarctic ice sheets also experienced melting, though on a smaller scale. Could this have been enough to expose significant portions of Antarctic coastline? Most glaciologists would say no, arguing that even during the warmest parts of the Holocene, Antarctica remained substantially ice-covered. However, the possibility cannot be entirely ruled out, particularly for localized areas along the coast where melting might have been more pronounced. Another climate period that has attracted attention is the Pliocene epoch, which lasted from about 5.3 to 2.6 million years ago. During the mid-Pliocene warm period, roughly 3 million years ago, global temperatures were several degrees warmer than today, and sea levels were significantly higher. Geological evidence suggests that during this time, parts of the Antarctic ice sheet may have melted, particularly in West Antarctica where the ice is more vulnerable due to the low-lying bedrock. Some scientists have proposed that West Antarctica may have been ice-free or nearly so during the warmest phases of the Pliocene, while East Antarctica retained its ice sheet. This would have created a situation similar to what Buache's map depicts, a large ice-covered landmass in East Antarctica and a more fragmented, possibly ice-free region in West Antarctica. However, there is a critical problem with invoking the Pliocene as a time when Antarctica might have been explored and mapped. Modern humans did not exist during this period. Our species, Homo sapiens, evolved only about 300,000 years ago. Even if we consider earlier human ancestors, the genus Homo only emerged about 2 to 3 million years ago, right at the end of the Pliocene. The sophisticated maritime technology required to explore Antarctica would not have existed during this early period of human evolution. Unless we are willing to postulate either an incredibly advanced pre-human intelligence or some form of human-like civilization that arose and disappeared without leaving archaeological traces, the Pliocene explanation does not resolve the mystery. This brings us to consider the possibility of more recent, but still ancient, exploration of Antarctica. The period from about 15,000 to 10,000 years ago, at the end of the last ice age, was a time of dramatic climate change and human expansion. As the great ice sheets covering North America and Europe began to melt, sea levels rose by more than 120 meters, flooding vast coastal plains and forcing human populations to adapt to changing conditions. This was also a period of remarkable human achievement. The megaliths of Göbekli Tepe in Turkey were erected around 11,000 years ago, demonstrating that even pre-agricultural societies were capable of impressive architectural feats requiring significant social organization and planning. In various parts of the world, humans were developing increasingly sophisticated tools, art, and social structures. Maritime technology was advancing as well, with evidence of boats and sea voyages dating back to this period. Could some human culture during this time have developed the capability to explore the southern oceans and even reach Antarctica? The conventional answer is no, but the possibility cannot be dismissed entirely. If we imagine a maritime culture developing along the coasts of South America, Southern Africa, or Australia, it is conceivable that some expeditions might have ventured progressively farther south, eventually encountering the edges of Antarctica or its surrounding ice fields. Even if they did not map the entire continent systematically, they might have observed enough to recognize the basic division between the two major land areas. The preservation and transmission of such knowledge over thousands of years presents its own challenges. How would information about Antarctic geography, observed 10,000 or 15,000 years ago, survive to be incorporated into 18th-century European maps? Writing systems did not exist for most of human history, so any information from the Ice Age would have had to be preserved through oral tradition, at least initially. However, we know that human societies are capable of preserving remarkably detailed information through oral transmission across many generations. Indigenous cultures around the world have maintained accurate oral histories, sometimes extending back thousands of years, that have been confirmed by archaeological and geological evidence. For example, Aboriginal Australians have oral traditions describing coastal landscapes that were flooded by rising sea levels at the end of the Ice Age, and these traditions have proven to be geographically accurate. If oral traditions can preserve information about specific landscapes for 10,000 years, it is at least conceivable that information about Antarctic geography could have been similarly preserved. Eventually, as writing and map-making developed, this orally transmitted knowledge could have been incorporated into written records and maps. These early maps would have been copied and recopied, with the information passing through multiple cultures and languages. Some details would have been lost or corrupted in transmission, but core geographical information might have remained relatively intact. This hypothetical chain of transmission would need to pass through several ancient civilizations known for their cartographic and navigational expertise. The Phoenicians, who dominated Mediterranean trade from about 1500 to 300 BCE, were renowned navigators who may have ventured beyond the Mediterranean into the Atlantic and possibly even around Africa. Some historians believe that Phoenician navigators circumnavigated Africa as early as 600 BCE, though this remains disputed. If Phoenicians or their predecessors had access to older navigational knowledge from even earlier seafaring cultures, they might have incorporated this information into their own maps and sailing directions. These Phoenician maps could then have been consulted by later Greek and Roman geographers. Ptolemy's geography, compiled in the 2nd century CE, drew on a wide range of sources, including older Phoenician and Greek maps that no longer survive. Ptolemy's maps were copied extensively during late antiquity and the medieval period, and they eventually reached Renaissance Europe where they became foundational texts for the revival of geographical learning. If ancient information about Antarctica had been incorporated into this classical geographical tradition, even if imperfectly understood or partially corrupted, it might have survived in various manuscript copies and derivative maps. The Islamic Golden Age, from roughly the 8th to the 14th centuries, was another crucial period for the preservation and transmission of geographical knowledge. Arab scholars translated and preserved many Greek and Roman texts that would otherwise have been lost, including geographical works. They also conducted their own explorations and compiled their own maps, sometimes incorporating information from sources that predated the Islamic period. When these Arabic geographical texts and maps reached Europe during the Renaissance, they brought with them knowledge that had been unavailable to medieval European scholars. The Piri Reis map of 1513, which shows what some interpret as an ice-free Antarctic coastline, was explicitly based on older source maps, including some that Piri Reis attributed to the time of Alexander the Great. If Piri Reis had access to ancient maps showing Antarctica, it is plausible that other Renaissance and early modern cartographers, including Buache, might have had access to similar or related sources. The royal libraries and archives of European powers contained extensive collections of maps and geographical texts gathered from around the Mediterranean and beyond. Some of these documents had complex provenances, having passed through multiple hands and cultures before reaching Europe. Buache, with his privileged access to the French royal collections, would have been in an excellent position to encounter such materials. We must also consider the possibility that Buache sources were not maps in the modern sense but rather written descriptions or sailing directions that described Antarctic geography in textual form. Ancient navigators often relied on written periploi, essentially sailing handbooks that described coastlines, landmarks, distances, and hazards. These texts were practical guides for navigation rather than maps per se, but they contained detailed geographical information that could be used to construct maps. If ancient sailing directions describing the Antarctic coast had survived, either in original form or through copies and translations, Buache or his predecessors could have used them to create visual maps. This might explain why the Buache map has accurate large-scale features but lacks fine detail. The source descriptions might have provided general information about the configuration of the continent without including the kind of detailed coastal topography that would come from systematic surveying. A sailing text might have described Antarctica as consisting of two land areas separated by a navigable channel without providing precise measurements or detailed coastal descriptions. This would have been sufficient for Buache to create the map he published, with its accurate general configuration but simplified coastlines. The question of accuracy versus speculation in pre-modern cartography is complex and does not have simple answers. Modern historians of cartography recognize that ancient and medieval maps often combined elements of accurate observation with theoretical constructs and artistic conventions. A single map might show some regions with great accuracy, based on direct surveying or reliable reports, while other regions might be depicted based on rumor, speculation, or philosophical principles. Mapmakers did not always clearly distinguish between these different types of information, and users of maps had to develop their own skills in evaluating the reliability of different portions of a map. In the case of the Buache map, we face the challenge of determining which elements represent genuine geographical knowledge and which might be speculative. The division of Antarctica into two landmasses is the most striking feature and the one that demands explanation, but other aspects of the map could be more conventional or speculative. For instance, The exact shape of the coastlines and the precise location of the dividing channel might have been refined or adjusted by Buache based on theoretical considerations, even if the basic concept of a divided continent came from his sources. This makes the interpretive task more difficult but also more interesting. We cannot simply accept or reject the map as a whole. We need to analyze it feature by feature, considering which aspects are most likely to represent accurate ancient knowledge and which might be later additions or modifications. Comparing the Buache map with other contemporary and near-contemporary maps of Antarctica or Terra Australis provides additional context for evaluating its accuracy and significance. Several other maps from the 16th through 18th centuries show Antarctic or subantarctic regions with varying degrees of accuracy and detail. The Orontius Phineas map of 1531 is perhaps the most famous of these. It shows a large continent labeled Terra Australis positioned at the South Pole, with a generally circular outline and various geographical features including mountains, rivers, and coastal inlets. The proportions and shape of the continent on the Orontius Phineas map bear some resemblance to the actual shape of Antarctica, though the correlation is not as precise as with the Buache map. What is particularly interesting about the Orontius Phineas map is that it shows an ice-free Antarctica with what appear to be interior geographical features, rivers, mountain ranges, and bays that would only be visible if the ice sheet were absent. Some researchers have argued that these features correspond to actual subglacial topography, though this claim is contested. If the Orontius Phineas map does contain accurate information about ice-free Antarctic geography, it would strengthen the case that there was a tradition of ancient maps showing Antarctica in a different climatic state. The Mercator World Map of 1569 provides another point of comparison. Gerardus Mercator, one of the most accomplished cartographers of the Renaissance, showed Antarctica on his world map as a large landmass surrounding the South Pole. Mercator's Antarctica is labeled with various place names and includes details of coastline and interior geography, though how much of this was based on actual information versus speculation is unclear. What is significant is that Mercator, like Buache after him, was working within a cartographic tradition that assumed Antarctica existed and that attempted to depict it with some degree of geographical specificity. Mercator had access to extensive collections of older maps and texts, and he was known for carefully evaluating his sources and attempting to incorporate the most reliable information available. If Mercator believed there was credible information about Antarctic geography, this lends some support to the idea that such information existed in Renaissance sources. Another relevant map is the Schöner Globe of 1515, created by the German cartographer Johannes Schöner. This globe shows a southern continent with considerable detail, including what appears to be a strait or passage through the continent. If this strait represents knowledge of the division between East and West Antarctica, it would predate the Buache map by more than 2 centuries and suggest that this information was more widely distributed in Renaissance cartographic sources than is sometimes assumed. The accumulation of these various maps showing Antarctica with unexpected accuracy or detail creates a pattern that is difficult to explain through conventional historical narratives. Each individual map might be explained away as coincidence, artistic interpretation, or fortunate guessing. But when we consider them collectively, the pattern becomes more compelling. Multiple cartographers, working in different times and places, using different source materials, all created maps showing aspects of Antarctic geography that would not be confirmed until centuries later when modern technology finally allowed systematic exploration and mapping of the continent. This pattern suggests the existence of a body of geographical knowledge about Antarctica that existed in pre-modern times, was incorporated into various maps and texts, and was eventually lost or forgotten as the original sources disappeared or became inaccessible. The Buache map represents perhaps the clearest and most precise example of this tradition, but it is not an isolated case. It is part of a larger phenomenon that challenges our understanding of the history of geographical exploration and the transmission of knowledge across centuries and civilizations. To evaluate these maps properly, we need to consider not only their accuracy but also their errors and limitations. No ancient or medieval map shows Antarctica with complete accuracy. All of them contain distortions, omissions, and speculative elements. The coastlines are simplified, the proportions are often incorrect, and the interior geography is either absent or highly stylized. These imperfections are exactly what we would expect if the maps were based on ancient observations that had been copied and recopied through multiple generations of cartographers, each introducing their own errors and modifications. The remarkable thing is not that the maps contain errors but that they contain as much accurate information as they do. If these maps were purely speculative or if they were based solely on philosophical theories about what should exist at the South Pole, we would not expect to find the specific correct details that they contain. The division of Antarctica on the Buache map, the overall shape of the continent on the Orientius-Phineus map, and the various other correlations between these ancient maps and modern geographical knowledge all represent information that is difficult to explain as arising from speculation or theory alone. The breakthrough that would eventually confirm the extraordinary accuracy of Philippe Buache's 1737 map came more than 2 centuries later, during one of the most ambitious scientific endeavors of the 20th century. The International Geophysical Year of 1957 to 1958 represented an unprecedented level of international scientific cooperation, bringing together researchers from 67 countries to conduct coordinated studies of Earth's geophysical phenomena. Among the many research programs undertaken during this period, the systematic exploration and mapping of Antarctica stood out as particularly significant. Scientists had long recognized that Antarctica held crucial information about Earth's climate, geology, and ice dynamics, but the continent's extreme conditions and remote location had made detailed study nearly impossible. Previous expeditions had explored coastal regions and made brief forays into the interior, but no comprehensive survey of the continent's structure had been attempted. The International Geophysical Year changed this situation dramatically, as multiple nations established research stations across Antarctica and deployed teams of scientists equipped with new technologies specifically designed for polar research. Among these technologies, seismic reflection and refraction techniques proved to be revolutionary, allowing researchers to finally see through the ice and map the bedrock topography that lay hidden beneath. The seismic surveys conducted during 1957 and 1958 involved teams of scientists and support personnel who traveled across vast stretches of Antarctic ice, often in extremely challenging conditions. The basic technique involved creating artificial seismic waves, typically by detonating small explosive charges on the ice surface, and then recording how these waves traveled through the ice and reflected off the bedrock below. By analyzing the travel times of these seismic waves and the patterns of their reflections, researchers could calculate the thickness of the ice and determine the elevation of the bedrock beneath it. This process had to be repeated at thousands of locations across the continent to build up a comprehensive picture of Antarctic topography. The work was slow, dangerous, and technically demanding. Equipment had to function in temperatures that regularly dropped below -40 degrees Celsius. Personnel had to contend with blizzards, crevasses, and the constant risk of mechanical failures in conditions where rescue might be impossible. Yet despite these challenges, the survey teams persevered, gradually accumulating data that would revolutionize scientific understanding of Antarctica. As the data from different survey teams was compiled and analyzed, a picture began to emerge that astounded the researchers. Antarctica was not the simple, unified continent that many had imagined. Instead, it consisted of two fundamentally different geological regions with a profound division between them. The data revealed that East Antarctica was indeed a massive continental platform, with bedrock rising well above sea level across most of its extent. Even accounting for the enormous weight of the ice sheet, which depresses the crust, much of East Antarctica's bedrock would remain above sea level if the ice were removed. This was consistent with geological theories that identified East Antarctica as a fragment of the ancient supercontinent Gondwana, built on stable continental crust that had remained largely unchanged for hundreds of millions of years. The seismic surveys mapped the contours of this buried landscape, revealing mountain ranges, valleys, and plateaus hidden beneath the ice. Some of these features were enormous. The Gamburtsev Mountains, discovered during these surveys, proved to be a range comparable in size to the European Alps, yet completely invisible from the surface because they were buried under more than 600 meters of ice. The discovery of such dramatic topography beneath the ice demonstrated just how little was known about Antarctica's true geography. If mountain ranges of this magnitude could remain undiscovered until the space age, what other features might be hiding beneath the ice? The East Antarctic Survey results were surprising, but they generally confirmed expectations that this region was a substantial, stable continent. The real shocks came from West Antarctica. West Antarctica presented a completely different picture. The seismic data showed that much of West Antarctica's bedrock lay below sea level, in some places more than 2,500 meters below. Without the ice sheet holding it together, West Antarctica would not be a unified landmass at all but rather an archipelago of mountainous islands separated by deep channels and basins. The Antarctic Peninsula would remain above water as a long mountainous spine extending toward South America. Several other mountainous regions, including the Ellsworth Mountains and the Executive Committee Range, would form substantial islands. But the vast Marie Byrd Land region and other areas would be largely submerged. The channels between these islands would in many cases be quite deep, forming substantial seaways that would allow ocean currents to flow freely through what is currently solid ice sheet. The deepest of these features, the Bentley Subglacial Trench, plunges to 2,555 meters below sea level at its lowest point, making it one of the lowest points on Earth's continental surface. This trench and other deep basins in West Antarctica are the result of crustal thinning caused by the West Antarctic Rift System, a zone of geological extension that has been pulling the crust apart for millions of years. The rifting has created the fundamental geological distinction between West and East Antarctica, a distinction that the seismic surveys had now revealed in unprecedented detail. The boundary between these two regions runs roughly along the line of the Transantarctic Mountains, one of the longest mountain ranges in the world, stretching more than 3,500 kilometers across the continent. These mountains mark the edge of the stable East Antarctic Craton and the beginning of the tectonically complex West Antarctic region. The seismic surveys traced this boundary with precision, showing that it was not a simple linear feature but a complex zone of transition involving multiple geological structures. In some places, the Transantarctic Mountains form a dramatic escarpment rising thousands of meters from the surrounding ice. In other places, the transition is more gradual or is interrupted by valleys and channels that cut through the mountain range. One of the most significant of these channels is the region where the ice streams from East Antarctica flow through gaps in the mountains and merge with West Antarctic ice. If the ice were removed, these channels would become waterways connecting the two regions, creating passages similar to what Buache had drawn on his 1737 map. The configuration revealed by the seismic data matched Buache's depiction with startling accuracy. He had shown Antarctica divided into two landmasses by a waterway running roughly east to west. The seismic surveys confirmed that this was essentially correct. Remove the ice, and Antarctica would indeed appear as two distinct land areas separated by waterways. When scientists first recognized this correspondence between the Buache map and the seismic survey data, reactions ranged from fascination to skepticism. Some researchers immediately grasped the profound implications of this correlation. If Buache's map accurately depicted the subglacial topography of Antarctica, then his claims about using ancient sources demanded serious consideration. How else could an 18th-century cartographer have known about geographical features that were hidden beneath miles of ice? Other scientists were more cautious, suggesting that the correlation might be less precise than it initially appeared or that it could be explained as coincidence. They pointed out that any map showing Antarctica divided into two parts would have some probability of matching reality simply because there are limited ways to divide a roughly circular continent. However, as more detailed comparisons were made between the Buache map and the seismic data, the correspondence proved to be more specific than could be easily dismissed as chance. The location of the dividing waterway, the relative sizes of the two landmasses, and the general configuration all aligned with the actual subglacial geography in ways that suggested genuine knowledge rather than lucky guessing. The debate over the significance of the Buache map intensified during the 1960s and 1970s as additional Antarctic surveys refined the picture of the continent's structure. The technology for mapping Antarctica's bedrock continued to improve dramatically in the decades following the International Geophysical Year. Airborne radar systems allowed researchers to survey vast areas much more quickly than ground-based seismic teams could. These ice-penetrating radar systems, operating at frequencies specifically chosen to pass through ice with minimal attenuation, could measure ice thickness continuously as aircraft flew survey lines across the continent. By the 1970s, multiple Antarctic research programs were conducting extensive airborne radar surveys, gradually building up comprehensive coverage of the entire continent. The data from these surveys confirmed and refined the picture that had emerged from the earlier seismic work. East Antarctica was indeed a high-standing continental block, while West Antarctica was a complex system of subglacial islands and basins. The resolution of the radar data allowed scientists to map not just the general topography but fine details of the bedrock surface, revealing features as small as individual valleys and ridges buried beneath the ice. This detailed mapping made it possible to create accurate visualizations of what Antarctica would look like without its ice sheet, and these visualizations bore remarkable resemblance to the configuration Buache had drawn in 1737. Satellite technology added yet another dimension to Antarctic mapping capabilities. Beginning in the 1990s, satellites equipped with radar altimeters began systematically measuring the elevation of Antarctica's ice surface with unprecedented accuracy. These measurements allowed scientists to map subtle variations in ice surface elevation that reflected the topography of the bedrock beneath. Where the bedrock was high, the ice surface tended to be elevated. Where deep basins existed in the bedrock, the ice surface showed corresponding depressions. By combining satellite altimetry data with ice-penetrating radar measurements and seismic surveys, researchers created increasingly sophisticated models of Antarctic bedrock topography. More recent satellite missions have used gravity measurements to refine these models further. The Gravity Recovery and Climate Experiment, or GRACE, satellites measured tiny variations in Earth's gravitational field caused by variations in mass distribution beneath the surface. These gravity measurements provided information about bedrock density and structure that complemented the direct topographic measurements from radar and seismic surveys. The result of all this technological effort has been a remarkably detailed picture of what lies beneath Antarctica's ice, and this picture consistently confirms the basic accuracy of Buache's 1737 depiction of the continent as two distinct landmasses separated by a waterway. The geological processes that created Antarctica's divided structure are now well understood through decades of research in plate tectonics and crustal dynamics. East Antarctica, as mentioned earlier, is a fragment of Gondwana, assembled from several ancient continental blocks that collided and fused together between about 600 and 500 million years ago during a period of mountain building known as the Pan-African orogeny. The rocks of East Antarctica include some of the oldest on Earth, with ages exceeding 3 billion years in some areas. This ancient continental core has remained relatively stable since its formation, resisting the tectonic forces that have shaped other parts of the planet. When Gondwana began to break apart starting about 180 million years ago, East Antarctica remained as the central piece around which the other continents separated. Africa pulled away to the north, India moved northward on its eventual collision course with Asia, Australia separated to the east, and South America moved westward. Through all of these continental movements, East Antarctica stayed in its polar position, gradually accumulating the ice sheet that would eventually bury its landscape. The stability of East Antarctica's geology is reflected in its topography, with the bedrock generally remaining above sea level even when adjusted for the weight of the overlying ice. West Antarctica's history is dramatically different and much more complex. Rather than being a single stable block like East Antarctica, West Antarctica is an assemblage of multiple smaller crustal fragments that were swept together by plate tectonic processes during the Mesozoic and Cenozoic eras. These fragments, technically called terranes, represent pieces of oceanic crust, volcanic island arcs, and small continental slivers that collided with and accreted onto the edge of East Antarctica over millions of years. The process was similar to what is currently happening in Indonesia and the Western Pacific, where numerous islands and crustal fragments are being compressed and assembled by the convergent motion of tectonic plates. In West Antarctica, this accretionary process created a complex geological patchwork rather than a unified continental block. The crustal structure varies dramatically from one region to another, with some areas consisting of thick continental-type crust while others have thin, weak crust more similar to oceanic regions. This variable crustal structure has made West Antarctica particularly susceptible to rifting and extension. The West Antarctic Rift System, which began to form about 105 million years ago, has pulled the crust apart along a zone extending from the Ross Sea region through to the Antarctic Peninsula. This rifting has thinned the crust, created deep basins, and allowed the surface to subside below sea level in many areas. The rift system is still geologically active today, with ongoing seismic activity and volcanic eruptions demonstrating that the geological processes shaping West Antarctica continue in the present. Mount Erebus, located on Ross Island at the edge of the West Antarctic Rift System, is one of the most active volcanoes on Earth, with a permanent lava lake in its summit crater. Several other volcanic centers in West Antarctica have erupted in recent geological time, and geophysical monitoring shows that magma continues to move through the crust beneath parts of the region. This volcanic and seismic activity is a direct consequence of the rifting process, which has thinned the crust enough to allow hot mantle material to rise close to the surface. The heat from this volcanic activity has important implications for the ice sheet above, as it creates regions where the base of the ice sheet is melted, allowing the ice to slide more easily. Some scientists have suggested that this geothermal heating may make the West Antarctic ice sheet particularly vulnerable to collapse if climate warming reduces its overall mass. The complex geology of West Antarctica, with its thin crust, deep basins, and ongoing tectonic activity, creates a fundamental distinction from the stable, high-standing East Antarctic continent. This distinction, revealed in full detail only through decades of modern geophysical research, was apparently understood in some form by whoever created the ancient maps that ultimately reached Philippe Buache. The question of how ancient observers might have recognized the division between East and West Antarctica depends critically on the climate conditions at the time of observation. If Antarctica was completely ice-covered, as it has been for millions of years according to standard geological evidence, then recognizing the fundamental distinction between the two regions would have been nearly impossible without modern technology. The ice sheet buries all details of the underlying topography, presenting a smooth, featureless surface that gives no indication of the complexity beneath. However, if we allow for the possibility that Antarctica was significantly less ice-covered at some point during the period when humans might have explored it, the situation changes dramatically. Even a modest reduction in ice extent would have revealed the topographic differences between East and West Antarctica. The high-standing terrain of East Antarctica would have remained as a substantial ice cap even during warm periods, much like Greenland's ice sheet persists today despite being surrounded by ice-free coastlines. West Antarctica, with its low-lying topography, would have responded much more dramatically to any reduction in ice volume. Areas that are currently buried under ice would have been exposed as islands or shallow seas. The channels between these islands would have been navigable waterways, allowing ships to sail through what is now solid ice sheet. The paleoclimate evidence for warmer conditions in Antarctica during relatively recent geological time remains controversial but cannot be entirely dismissed. While the mainstream view holds that Antarctica has been substantially ice-covered for at least 14 million years and possibly as long as 34 million years, some research has suggested more variability. Studies of sediment cores from the ocean floor around Antarctica have identified periods during the Pliocene epoch, roughly 3 to 5 million years ago, when temperatures were warmer and when parts of the Antarctic ice sheet may have been reduced or absent. During the warmest phases of the Pliocene, global average temperatures were about 2 to 3 degrees Celsius warmer than today, and sea levels were 15 to 25 meters higher than present, indicating that significant amounts of ice had melted from somewhere. Some of this melting came from Greenland and from Mountain Glacier, but the high sea levels of the Pliocene also suggest that Antarctic ice volume was reduced. If West Antarctica lost most or all of its ice during these warm periods while East Antarctica retained its ice sheet, the result would have been a configuration similar to what Buache's map depicts, a large ice-covered landmass in the east and a more fragmented region of islands and channels in the west. The critical problem with this scenario, as noted earlier, is the timing. The Pliocene ended nearly 3 million years ago, long before anatomically modern humans evolved. Unless we postulate some unknown precursor civilization capable of maritime exploration and cartography, the Pliocene warm periods cannot explain the Buache map. More recent warm periods present different challenges and possibilities. The last interglacial period, which occurred about 125,000 years ago, was slightly warmer than our current interglacial, and some evidence suggests that sea levels may have been 6 to 9 meters higher than today. This indicates that some ice melting occurred, possibly including partial collapse of West Antarctic ice. However, 125,000 years ago is well before the emergence of sophisticated human cultures capable of long-distance maritime navigation. The early Holocene, from about 11,000 to 8,000 years ago, was another warm period when global temperatures reached levels similar to or slightly above current temperatures. This period saw the final melting of the great ice sheets that had covered North America and Northern Europe during the last ice age. Sea levels rose rapidly as this ice melted, flooding coastal areas around the world and forcing human populations to adapt to dramatically changing coastlines. Some researchers have proposed that Antarctic ice may also have been affected during this period, with possible reduction in ice extent particularly in coastal regions of West Antarctica. The timing of this warm period is more compatible with human exploration and mapping, as sophisticated maritime cultures certainly existed by this time. The challenge is finding evidence that any such cultures had the capability and motivation to explore as far south as Antarctica. No archaeological or historical evidence currently supports the existence of such long-distance maritime expeditions during the early Holocene, but absence of evidence is not conclusive proof of absence, particularly for maritime cultures whose settlements would have been concentrated along coastlines that are now submerged. The transmission mechanism by which information about Antarctica could have survived from the early Holocene to the 18th century remains one of the most difficult aspects of this mystery to explain satisfactorily. Even if we accept that some ancient culture explored and mapped Antarctica when it was more accessible, we must still account for how this knowledge survived through the intervening millennia. Oral transmission could preserve some information, as demonstrated by various indigenous cultures whose oral histories contain accurate geographical and historical information spanning thousands of years. However, the level of specific detail shown on the Buache map would be difficult to maintain through purely oral transmission, as details tend to become simplified or distorted when passed down through many generations of retelling. Written records and maps would provide more reliable preservation, but this requires that the exploring culture had developed writing and cartography, and that their documents survived or were copied by subsequent civilizations. The ancient Mediterranean world, with its succession of literate civilizations trading and sharing knowledge across wide areas, could have served as a conduit for geographical information from earlier periods. The famous Library of Alexandria, though most of its contents are now lost, once contained hundreds of thousands of manuscripts gathered from around the known world. Some of these texts dated back to very ancient times and preserved knowledge from cultures that had long since disappeared. When the library's contents were dispersed and partially destroyed during late antiquity, many manuscripts made their way into other collections in Byzantium, the Islamic world, and eventually Europe. Could some of these manuscripts have contained information about Antarctic geography? The historical record does contain tantalizing hints of ancient geographical knowledge that extended beyond the regions normally associated with classical Mediterranean civilizations. The Greek historian Herodotus, writing in the 5th century BCE, described how Phoenician navigators in the service of the Egyptian pharaoh Necho had circumnavigated Africa, sailing south from the Red Sea, around the Cape of Good Hope, and north through the Atlantic to return to the Mediterranean. Herodotus himself expressed skepticism about this account, but modern historians generally accept it as plausible, and the navigator's description of the sun's position during their southern voyage actually supports the story's authenticity. If Phoenician navigators in the 7th century BCE were capable of circumnavigating Africa, a voyage that would have taken them through the southern Atlantic to latitudes approaching 35 degrees south, it demonstrates a level of maritime capability that exceeds what is usually assumed for ancient civilizations. Could such capable navigators have ventured even farther south? Another intriguing piece of evidence comes from Plutarch's account of the geographer Crates of Mallos, who in the 2nd century BCE created a globe showing the Earth divided into 4 landmasses by ocean channels running along the equator and a meridian. According to Crates, there were inhabited lands in the southern hemisphere that corresponded to the known lands of the northern hemisphere. While this might have been purely theoretical, based on ideas about symmetry and balance, it is also possible that Crates was drawing on older traditions or reports about southern lands. The hypothesis that ancient sources contained accurate information about Antarctica faces significant challenges from mainstream archaeology and history, yet the existence of the Buache map and similar cartographic anomalies continues to demand explanation. To understand the full scope of this mystery, we must examine the question of whether Antarctica could have been accessible to human exploration at any point during the timeframe that would allow for the creation and transmission of maps. The standard scientific model holds that Antarctica has been covered by ice for millions of years, far predating the emergence of human civilization. Ice core data extracted from the Antarctic ice sheet provides a continuous climate record extending back more than 800,000 years, and this record shows that temperatures have remained cold enough to maintain the ice sheet throughout this entire period. However, ice cores can only sample the ice that currently exists. They cannot tell us definitively about conditions in areas where ice may have been absent in the past. This leaves open the theoretical possibility that certain regions of Antarctica, particularly in West Antarctica where the bedrock lies below sea level and ice stability is marginal, might have experienced temporary ice reduction during warm periods even if the bulk of the continent remained frozen. The geological evidence bearing on this question comes from multiple sources, each with its own limitations and interpretive challenges. Marine sediment cores taken from the ocean floor around Antarctica contain layers of material that were eroded from the continent and transported to the ocean by ice streams, glacier, and meltwater. By analyzing the composition and characteristics of these sediments, geologists can infer conditions on the Antarctic continent at various times in the past. Some sediment cores have revealed layers dating to the Pliocene epoch that contain material suggesting warmer conditions and possibly reduced ice cover. For instance, sediments containing pollen grains from land plants indicate that vegetation grew on Antarctica during certain Pliocene intervals, which would require ice-free land areas and temperatures well above freezing during at least part of the year. Additionally, some sediment layers contain diatoms, microscopic algae that live in open water, in abundances suggesting that parts of Antarctica's continental shelf were ice-free and supported productive marine ecosystems. These findings have led some scientists to propose that during the warmest phases of the Pliocene, approximately 3 to 3.5 million years ago, the West Antarctic ice sheet may have collapsed partially or completely while East Antarctica retained its ice cover. This scenario fits well with the fundamental geological distinction between the two regions, as West Antarctica's low-lying topography makes it inherently less stable than East Antarctica's high plateau. However, translating these geological findings into a clear picture of what Antarctica looked like during warm periods remains challenging. The sediment core data provides snapshots of conditions at specific locations and times, but connecting these snapshots into a comprehensive reconstruction requires making assumptions about how climate change affected different parts of the continent. Computer models of ice sheet behavior during past warm periods attempt to simulate these dynamics, but the models must rely on imperfect knowledge of past climate conditions and of the physical properties of ice and bedrock. Different modeling approaches sometimes produce significantly different results, leading to ongoing scientific debates about exactly how much ice was lost during various warm periods and which regions were most affected. Most models agree that if significant ice loss occurred, it would have been concentrated in West Antarctica, where marine-based ice sitting on bedrock below sea level is particularly vulnerable to warming ocean temperatures. Under such conditions, West Antarctica might have appeared as a collection of mountainous islands surrounded by ocean, with only the highest peaks and ridges rising above sea level. East Antarctica, by contrast, would have retained a substantial ice sheet, though its edges might have retreated somewhat and its coastal areas might have been more accessible than today. This configuration matches the general pattern shown on the Buache map, with a large landmass in the east and a more fragmented region in the west. The challenge of reconciling this geological scenario with human history centers on the question of timing. The Pliocene warm periods occurred millions of years before humans evolved, while more recent warm periods during the Pleistocene and Holocene epochs appear to have been insufficient to cause large-scale collapse of Antarctic ice. This creates what seems like an insurmountable chronological barrier to any explanation involving direct human observation of a less ice-covered Antarctica. However, some researchers have pointed to uncertainties in both the geological record and in our understanding of past climate dynamics that might leave room for alternative scenarios. One such uncertainty involves the possibility of abrupt climate transitions during the late Pleistocene that might have temporarily affected Antarctic ice. The period from roughly 50,000 to 10,000 years ago was characterized by dramatic and sometimes rapid climate fluctuations, including sudden warming events known as Dansgaard-Oeschger events that occurred repeatedly during the last ice age. These events, recorded in Greenland ice cores and in marine sediments, show that regional temperatures could increase by several degrees within just a few decades, remain warm for centuries or millennia, and then cool again equally rapidly. Most of these events were confined to the northern hemisphere, but some climate signals appear to have been transmitted globally, raising questions about whether Antarctic climate might have been affected in ways not yet fully understood. Another area of uncertainty involves the response of Antarctic ice shelves to ocean warming. Ice shelves are floating extensions of the ice sheet that extend out over the ocean, and they play a crucial role in stabilizing the ice sheet by buttressing the glacier that flow into them from inland. When ice shelves collapse, the glacier behind them can accelerate dramatically, increasing ice discharge to the ocean and potentially triggering rapid ice loss. Modern observations have documented several major ice shelf collapses in recent decades, including the dramatic disintegration of the Larsen B ice shelf in 2002, which broke up completely in just a few weeks after having been stable for thousands of years. These observations have led scientists to recognize that ice shelves can cross tipping points beyond which collapse occurs very rapidly. Could similar abrupt collapses have occurred in the past, possibly during warm intervals within the last ice age, creating temporary windows when parts of Antarctica were more accessible? The geological record is not detailed enough to definitively rule out such short-lived events, particularly if they lasted only decades or centuries before ice reformed. If such events occurred, and if they happened to coincide with periods when capable maritime cultures existed in the southern hemisphere, it is conceivable that explorers might have encountered and mapped parts of Antarctica during these brief warm windows. This scenario remains highly speculative and is not supported by current mainstream scientific evidence, but it illustrates the kinds of possibilities that have been proposed to explain the Buache map and similar anomalies. Another approach to the mystery focuses less on whether Antarctica was ice-free and more on whether ancient civilizations might have had the technological capability to explore and map Antarctica even if it was ice-covered. Modern Antarctic exploration requires advanced technology, including ice-strengthened ships, cold-weather clothing and equipment, sophisticated navigation instruments, and extensive logistical support. The idea that any ancient or medieval culture could have matched these capabilities seems implausible at first consideration. However, some researchers have pointed out that we may be underestimating the technological achievements of past civilizations, particularly in the realm of maritime technology and navigation. The Polynesian navigators who settled the remote islands of the Pacific demonstrated extraordinary seafaring abilities, successfully navigating across thousands of kilometers of open ocean using techniques that were not fully understood or appreciated by Europeans until recent decades. Polynesian navigators used detailed knowledge of ocean swells, star positions, bird behavior, and other natural signs to maintain their course and find small islands in the vast Pacific. They accomplished this without compasses, sextants, or written charts, relying instead on extensive training and memorized information passed down through generations. Their voyaging canoes, while seemingly simple compared to European ships, were remarkably seaworthy and capable of long ocean passages. Could similar or even more advanced maritime technologies have existed in other times and places, perhaps leaving fewer traces in the archaeological record? The question of what technologies might have been lost or forgotten by later civilizations is a recurring theme in discussions of ancient achievements that seem to exceed conventional expectations. We know from historical examples that technological knowledge can indeed be lost when civilizations collapse or when economic and social conditions change. The Romans developed sophisticated concrete technology that enabled them to construct massive buildings and infrastructure works that have survived for 2 millennia, yet the specific formulations and techniques they used were forgotten during the medieval period and only rediscovered and recreated in modern times. Similarly, the medieval Islamic world achieved remarkable advances in mathematics, astronomy, and engineering, much of which was initially unknown to medieval Europe and only gradually transmitted westward through translation programs in Spain and Sicily. These examples demonstrate that technological knowledge is not necessarily preserved automatically but depends on institutions, practices, and economic conditions that support its transmission. If a maritime civilization with advanced navigational capabilities had existed in the ancient world but subsequently declined or was destroyed, it is conceivable that much of their specialized knowledge could have been lost, with only fragmentary survivals in the form of maps and scattered references in texts. The Buache map and similar cartographic puzzles might represent such survivals, preserving information whose origins and context were forgotten even as the basic geographical content was copied forward through successive generations of mapmakers. Critics of these speculative scenarios correctly point out that they require us to accept several unlikely propositions for which we lack direct evidence. We must postulate either climatic conditions different from what geological data suggests, or technological capabilities beyond what archaeological evidence supports, or both. These are significant evidential burdens, and mainstream scholars are understandably reluctant to accept such propositions without compelling proof. However, defenders of the mystery argue that the alternative, dismissing the accuracy of the Buache map as mere coincidence, also requires accepting an unlikely proposition that an 18th-century cartographer, working without any knowledge of Antarctica's actual structure, somehow drew a map that matches reality in multiple specific ways purely by chance. When we weigh these competing unlikely scenarios against each other, the question becomes which is less improbable rather than which is definitively proven. This kind of evidential situation, where all available explanations face significant challenges, is not uncommon in historical and archaeological research. It reflects the fundamental difficulty of reconstructing past events from limited and fragmentary evidence. The responsible scholarly approach is to acknowledge the limitations of our knowledge while remaining open to new evidence and new interpretations that might eventually resolve the mystery. The broader context of controversial ancient maps extends beyond Antarctica to include several other cartographic anomalies that have generated similar debates. The Piri Reis map of 1513, mentioned earlier, is perhaps the most discussed of these. This map, discovered in 1929 in the Topkapi Palace in Istanbul, shows the coastlines of Western Africa, East and South America, and what some researchers interpret as the northern coast of Antarctica. The map includes extensive notes by Piri Reis explaining his sources and methods. He explicitly states that he compiled the map from approximately 20 older source maps, including maps captured from Spanish and Portuguese ships, maps dating from the time of Alexander the Great, and other ancient sources. Some features of the Piri Reis map appear remarkably accurate given the date of its creation. The South American coastline is depicted with considerable precision, including details of bays and river mouths that match modern maps. This accuracy is particularly notable because the region had been explored by Europeans only 20 years before Piri Reis created his map, and detailed surveys had not yet been conducted. The accuracy suggests that Piri Reis had access to high-quality Portuguese source maps showing the results of early explorations. More controversially, the southern portion of the Piri Reis map shows a coastline extending beyond the southern tip of South America that some researchers have identified as representing Antarctica or a subantarctic landmass. This identification is disputed, with critics arguing that the coastline more likely represents an exaggerated or misplaced depiction of Patagonia or the hypothetical Terra Australis. The debate over the Piri Reis map illustrates the interpretive challenges involved in analyzing ancient cartographic sources. Maps from this period often combined accurate information about some regions with speculative or erroneous information about others. Cartographers did not always clearly distinguish between areas they had reliable information about and areas where they were filling in gaps with educated guesses or copying conventional representations from earlier maps. This mixing of accurate observation and speculation makes it difficult to determine which features of a map should be taken as evidence of genuine geographical knowledge and which represent other factors. In the case of the Piri Reis map, even researchers who accept that much of the map is remarkably accurate disagree about whether the southern coastline represents Antarctica or something else. Those who argue for the Antarctica interpretation point to features of the coastline that seem to match the actual northern coast of Antarctica, particularly the pattern of mountains and valleys in the region. They note that Piri Reis himself indicated that his southern landmass was cold and mountainous, consistent with Antarctica. Those who argue against the Antarctica interpretation point out that the coastline on the map is positioned farther north than Antarctica actually lies, and that its orientation and shape do not match Antarctica when properly projected onto a globe. They argue that Piri Reis was more likely depicting an imaginary extension of South America or a conventional representation of Terra Australis rather than showing actual knowledge of Antarctica. Similar debates surround other controversial ancient maps. The Orontius Phineus map of 1531, created by the French cartographer Orensfine, shows a large Antarctic continent labeled Terra Australis with considerable geographical detail including mountains, rivers, and coastal features. The general shape of the continent on this map bears some resemblance to Antarctica, particularly in the depiction of the Antarctic Peninsula extending northward and the roughly circular form of the continent. Some researchers have argued that the Orientius-Phineas map shows Antarctica as it would appear without ice coverage, with rivers and interior geography representing features that are currently buried under the ice sheet. If this interpretation is correct, it would suggest that the map was based on sources depicting Antarctica in a warmer climatic state, which would push the ultimate origin of these sources back to a time before the current ice sheet formed. Skeptics counter that the apparent similarities between the Orientius-Phineas map and the actual shape of Antarctica are less precise than advocates claim, and that many of the specific features shown on the map do not correspond to real Antarctic geography. They argue that Orensfine was probably working within the conventional Renaissance tradition of depicting a large hypothetical southern continent and that any resemblances to the actual Antarctica are coincidental. The difficulty in resolving these debates stems from the fact that ancient maps were not created with the same cartographic standards and projections that modern maps use, making direct comparisons problematic. Different scholars using different analytical methods can arrive at quite different conclusions about whether a particular ancient map shows genuine knowledge of a region or not. The Zano map of 1558 presents another example of cartographic controversy, though involving northern rather than southern regions. This map, published by Niccolò Zano, purports to show the results of explorations in the North Atlantic by his ancestors in the 14th century. The map includes depictions of various islands and coastlines, some of which appear to show parts of North America and Greenland with surprising accuracy for such an early date. However, the map also includes non-existent islands and contains geographical errors that have led most historians to question its authenticity or reliability. Some researchers have argued that the Zano map was based on real exploration accounts but was corrupted or embellished by later copyists. Others have suggested that it is largely a fabrication, though possibly incorporating some genuine geographical information from various sources. The debates over the Zano map parallel in many ways the debates over Antarctic maps like those of Piri Reis and Orientius-Phineas. In all these cases, we are dealing with complex historical documents that may contain mixtures of accurate information, speculation, error, and possibly deliberate falsification. Untangling these elements requires careful analysis of the maps themselves, comparison with other historical sources, and evaluation of the broader historical context in which the maps were created. This analytical work is ongoing, and new technologies and methods continue to shed light on these old mysteries. For instance, computer analysis of the projections and mathematical properties of ancient maps can help determine whether they were constructed using systematic methods or were more speculative in nature. Similarly, improved understanding of historical exploration and navigation can help evaluate the plausibility of claims about ancient voyages and discoveries. Returning specifically to the Buache map and its relationship to modern knowledge of Antarctica, we can identify several specific features that demand explanation regardless of what broader theoretical framework we adopt. First, the map shows Antarctica divided into two distinct landmasses. This is not a feature that appears on most other 18th-century maps of Terra Australis, which typically showed the southern continent as unified. The division shown by Buache corresponds to the actual geological distinction between East and West Antarctica, a distinction that results from their different crustal structures and that is manifested in their different topographic elevations beneath the ice. Second, the relative sizes and proportions of the two landmasses on Buache's map roughly match the actual situation, with the eastern portion shown as larger and more substantial than the western portion. This matches the reality that East Antarctica is a large continental block while West Antarctica would be a smaller, more fragmented region if the ice were removed. Third, the location of the dividing waterway on Buache's map approximates the actual position of the Transantarctic Mountains and the associated rift system that separates the two regions. While the map does not show perfect accuracy in the placement of this feature, it is positioned in approximately the right area of the continent. Fourth, the overall outline and proportions of Antarctica on Buache's map are reasonably accurate, showing it as a polar continent of appropriate size rather than as an enormous landmass extending into lower latitudes as many speculative maps did. These multiple points of correspondence between the Buache map and reality create a cumulative case that is stronger than any single correlation might be. If the map showed only one feature correctly, we might more easily dismiss it as coincidence. But when multiple independent features all align with reality, the probability of pure chance decreases. To illustrate this point, we can perform a simple probabilistic thought experiment. Suppose we ask what the chances are that a randomly drawn map showing Antarctica divided into two parts would match reality in all these ways. We would need to specify how likely it is that the division would be placed in approximately the correct location, that the two parts would have approximately the correct relative sizes, that the overall proportions of the continent would be approximately correct, and so forth. Even if we assign relatively generous probabilities to each of these individual features, perhaps 20 to 30% chances that each feature would match by accident, the combined probability becomes quite low. If for independent features each have a 25% chance of matching correctly by accident, the probability that all four would match simultaneously by chance is approximately 0. For percent, or less than 1 in 200. This rough calculation should not be taken as a precise statistical proof, as it involves various assumptions about independence and probability that could be questioned. However, it illustrates why the multiple correlations in the Buache map present a more challenging puzzle than single isolated correlations would. The question of Buache sources remains central to evaluating his map. He claimed to be working from older maps, but he did not provide specific citations or describe these sources in detail. This lack of documentation is frustrating for modern researchers trying to verify his claims, but it was not unusual for 18th-century cartographers. The practices of scholarly documentation and citation that we take for granted today were less standardized in earlier periods. Cartographers typically did not list all their sources or explain their methodological decisions in the detailed way that modern scholars would expect. They were more focused on producing accurate and useful maps than on documenting the process by which those maps were created. However, the fact that Buache did mention that he was using older sources, even without providing full details, is significant. He was making a specific claim about the origin of his information, a claim that would have been understood by his colleagues at the French Royal Academy of Sciences. If Buache had simply been inventing or speculating about Antarctic geography, he could easily have presented his map without claiming ancient sources. The fact that he specifically attributed the information to older maps suggests that he believed this attribution was important and that his colleagues would find it credible. This in turn suggests that the existence of old maps containing geographical information whose origins were uncertain or mysterious was an accepted feature of the cartographic world in which Buache worked. The quest to identify Buache-specific sources has occupied researchers for decades, though with limited success. The French royal collections that Buache had access to in the 1730s contained thousands of maps, charts, and geographical manuscripts accumulated over centuries. Many of these documents have since been dispersed, lost, or remain uncatalogued in various archives. Some were destroyed during the French Revolution when royal properties were seized and redistributed. Others were damaged or lost during subsequent conflicts and upheavals. The result is that modern researchers cannot simply examine the collection that Buache used and identify which specific items might have influenced his Antarctic map. Instead, they must work backward from the map itself and from general knowledge about what kinds of materials were available in 18th century France, attempting to reconstruct what Buache might have seen. This detective work involves examining surviving maps and manuscripts from the period, looking for connections and similarities that might indicate shared sources. It also involves studying the notes and correspondence of Buache and his contemporaries, searching for mentions of ancient maps or unusual geographical information. While this research has not produced definitive answers, it has revealed that the world of 18th century cartography was more complex and internationally connected than is sometimes appreciated. European cartographers of Buache's era had access to geographical information from an remarkably diverse array of sources. The age of exploration had brought European navigators into contact with cultures around the world, and some of these cultures possessed their own cartographic traditions that predated European arrival. Chinese navigators had explored much of the Indian Ocean and Southeast Asian waters during the 15th century under the direction of the Admiral Zheng He, creating detailed charts of these regions. While most of these charts were later destroyed as part of a deliberate policy to end long-distance naval expeditions, some survived and may have been available to European traders and diplomats in China. Arab and Persian navigators had maintained sophisticated maritime networks across the Indian Ocean for centuries before Europeans arrived, and they possessed detailed knowledge of monsoon patterns, currents, and coastal geography throughout the region. Some of this knowledge was recorded in written sailing directions and charts that Europeans encountered when they entered the Indian Ocean trade. Ottoman geographers had access to Byzantine and Islamic cartographic traditions that preserved and built upon Greco-Roman geographical knowledge. The Piri Reis map demonstrates that Ottoman cartographers in the early 16th century had access to a wide range of source materials, including captured European charts and older Mediterranean maps. Could similar sources have made their way to France by Buache's time? The Ottoman Empire maintained diplomatic and commercial relations with France throughout the 17th and 18th centuries, creating opportunities for the exchange of books, maps, and other materials. Indigenous knowledge systems in various parts of the world also preserved geographical information that was sometimes remarkably accurate and detailed. Polynesian navigators possessed sophisticated understanding of Pacific geography, including knowledge of islands separated by hundreds or thousands of kilometers of open ocean. This knowledge was preserved through oral tradition, with master navigators training apprentices in complex systems of wayfinding that incorporated astronomical observations, ocean swell patterns, and other natural signs. While this knowledge was not recorded in the form of written maps until relatively recently, it demonstrates that non-literate societies could maintain and transmit detailed geographical information across generations. Similarly, Aboriginal Australians maintained extensive knowledge of the geography of their continent, including understanding of regions far beyond any individual's direct travel range. This knowledge was encoded in songs, stories, and ceremonial practices that served as mnemonic devices for remembering complex geographical information. When Europeans first encountered some of these indigenous knowledge systems, they often failed to recognize their sophistication and accuracy, dismissing them as mere folklore or superstition. Only more recently have researchers begun to appreciate that indigenous geographical knowledge often represents accumulated observations refined over thousands of years of experience. Could some ancient maritime culture have possessed similar detailed knowledge of Southern Ocean geography, knowledge that was eventually incorporated into map-making traditions even after the culture itself had disappeared or been absorbed into other societies? The theoretical possibility that geographical knowledge can be transmitted across vast spans of time through successive cultures copying and recopying maps raises interesting questions about how information degrades or transforms during transmission. Modern research into the transmission of information through copying has revealed that the process is not simply one of gradual degradation where accuracy inexorably declines with each generation of copying. Instead, the process is more complex, with some types of information being preserved quite accurately while other types are modified or lost. Distinctive features and prominent landmarks tend to be preserved better than subtle details. Large-scale patterns and relationships are maintained more reliably than precise measurements. The overall configuration of a geographical region might be preserved even as specific place names and fine details are altered or forgotten. This is consistent with what we observe in the historical record of map transmission. For instance, when we compare different manuscript copies of Ptolemy's geography from the medieval period, we find that while they differ in various details, they generally preserve the same overall geographical understanding. The relationships between different regions, the approximate positions of major features, and the general outline of coastlines remain consistent across different copies despite variations in specific details. If ancient maps of Antarctica underwent similar processes of transmission, we would expect to see exactly the pattern that the Buache map exhibits: correct large-scale features like the division of the continent into two regions, with simplified or stylized representation of specific coastlines and details. Another factor that may have contributed to the preservation of accurate geographical information in ancient maps is the practical utility of such information for navigation. Sailors and merchants who actually used maps for navigation would have had strong incentives to maintain accuracy in features that were relevant to their voyages. A map that showed coastlines in the wrong locations or that misrepresented the positions of islands would be useless or even dangerous for navigation. Market forces and practical necessity would have favored the preservation and transmission of accurate information, while inaccurate information would be corrected or discarded. This selective pressure toward accuracy might explain how certain features of ancient maps could remain correct through many generations of copying even as other aspects of the maps became corrupted or obsolete. If the division of Antarctica into two landmasses had practical significance for ancient navigators, perhaps because it indicated the existence of channels or passages that could be used for transit, this information might have been carefully preserved even as other less critical details were lost or altered. This hypothesis assumes that ancient navigators actually used Antarctica's channels, which requires that the channels were accessible, which in turn requires reduced ice coverage compared to today. We are thus brought back to the same chronological challenges discussed earlier, but the navigation utility hypothesis at least provides a mechanism by which specific accurate information could survive preferentially during transmission. The physical properties of maps as historical artifacts also merit consideration when evaluating the Buache map and similar documents. Unlike texts, which can be copied relatively easily and completely, maps present special challenges for reproduction. Before the development of printing technology, maps had to be copied by hand, a process that was time-consuming and prone to introducing errors. The copyist needed not only artistic skill to draw accurately but also some understanding of the geographical content to make intelligent decisions about how to represent features. Different copyists might interpret the same source map differently, leading to variations between copies. Additionally, maps often needed to be adapted when being copied, for instance to fit a different page size or to accommodate a different map projection. These adaptations required geographical and mathematical knowledge to execute properly. An unskilled copyist might introduce significant distortions when attempting to adapt a map to a new format. The development of woodblock printing and later copperplate engraving in the 15th and 16th centuries improved the reliability of map reproduction, allowing multiple identical copies to be produced from a single master. However, even printed maps required periodic updating as new geographical information became available, and these updates sometimes introduced errors alongside corrections. The chain of transmission from any hypothetical ancient source maps to Buache 1737 map would have involved multiple episodes of copying, adaptation, and updating, each presenting opportunities for information to be lost, corrupted, or modified. The fact that the Buache map preserves accurate large-scale features despite this long transmission process is remarkable and suggests that these features were strongly preserved throughout the transmission chain. The role of theoretical geography in shaping Renaissance and early modern maps must also be considered as we evaluate the Buache map. Cartographers of this period were not simply recording observed features but were also working within theoretical frameworks that influenced how they represented geographical information. One influential theoretical concept was the idea that the Earth must be balanced and symmetrical, with comparable amounts of land in different hemispheres. This concept, derived from ancient Greek philosophy, led many cartographers to include large southern continents on their maps even in the absence of observational evidence, simply because such continents were theoretically necessary for balance. However, the theoretical terra australis shown on most maps was typically enormous, extending across much of the southern hemisphere and often depicted as connected to South America, Africa, or Asia. Buache's Antarctica is different. It is modest in size, positioned at the South Pole rather than extending into temperate latitudes, and most distinctively, it is divided into two parts. None of these features follow naturally from the balance and symmetry theories that motivated most theoretical depictions of terra australis. If Buache had been working purely from theory, we would expect his Antarctica to look more like the conventional terra australis of other maps. The fact that his depiction diverges from theoretical expectations in ways that happen to match reality suggests that he was incorporating information from sources rather than simply following theoretical principles. The question of whether Buache himself believed that his Antarctic map showed real geography as opposed to theoretical construction is worth considering. His writings and presentations to the Royal Academy of Sciences suggest that he took the map seriously as a representation of actual geographical features. He did not present it as a philosophical speculation or as a mere illustration of theoretical principles. He claimed specific sources and implied that the information had empirical origins, even if those origins were ancient and no longer fully understood. His colleagues at the Academy appear to have received the map as a serious contribution to geographical knowledge rather than dismissing it as fanciful. However, the lack of any way to verify the map's accuracy in the 18th century meant that it remained in a kind of limbo, neither fully accepted nor definitively rejected. Some scholars probably viewed it with skepticism, while others may have found Buache's claims about ancient sources credible given the known examples of ancient geographical knowledge that had been preserved and transmitted through the centuries. The map would have been filed away as an interesting but unverifiable piece of geographical speculation, to be re-evaluated if and when Antarctica was finally explored and mapped. The fact that this re-evaluation, when it finally came in the 20th century, confirmed the map's accuracy rather than refuting it is what transforms it from a historical curiosity into a genuine mystery. The implications of the Buache map extend beyond the specific question of Antarctic geography to broader issues about how we understand human history and the development of civilization. If we accept that the map contains genuine ancient knowledge about Antarctica, we must revise our understanding of what ancient cultures were capable of achieving. This does not necessarily require us to postulate lost advanced civilizations with technology comparable to our own, but it does require us to recognize that some ancient cultures may have achieved more in certain specific domains, particularly in maritime exploration and navigation, than conventional historical narratives acknowledge. The history of technology is not a simple story of steady linear progress from primitive to advanced. Different cultures at different times have excelled in particular areas while remaining less developed in others. The Polynesians, as mentioned earlier, achieved remarkable sophistication in open ocean navigation while not developing writing systems or metal technology. The Inca created a vast empire with sophisticated administration, engineering, and agriculture without developing wheeled vehicles or a phonetic writing system. These examples remind us that technological development is uneven and that cultures can be highly advanced in some domains while appearing less developed in others when judged by different criteria. An ancient maritime culture that excelled at long-distance navigation and geographical observation might have left relatively little archaeological trace if their settlements were primarily coastal and if their technology was based primarily on organic materials like wood, fiber, and animal products that decay relatively quickly. The challenge of detecting ancient maritime cultures in the archaeological record is a real one that archaeologists have increasingly recognized. Coastal settlements that were occupied during periods of lower sea level are now submerged and difficult to locate and excavate. The artifacts and structures associated with maritime activities are often made from perishable materials that do not preserve well. Boats, ropes, sails, and navigational instruments made from wood, fiber, and other organic materials typically survive only under exceptional conditions of preservation. This means that a culture that was highly sophisticated in maritime technology might be nearly invisible archaeologically unless we are fortunate enough to find sites with unusual preservation or unless we specifically search in the right locations using appropriate methods. Underwater archaeology has begun to reveal more about ancient maritime activities, with discoveries of shipwrecks, submerged settlements, and ancient harbor works providing new insights into the capabilities of past seafaring cultures. However, systematic underwater archaeological surveys of continental shelves, where ancient coastal settlements would be located, remain limited due to the expense and technical challenges involved. Large areas of potentially significant archaeological sites remain unexplored beneath the oceans. This means that absence of archaeological evidence for ancient maritime cultures with advanced capabilities is not conclusive proof that such cultures did not exist. It may simply reflect the limitations of what we have searched for and where we have looked. Recent archaeological discoveries have repeatedly demonstrated that human capabilities in the ancient and prehistoric past were often more sophisticated than previously assumed. The megalithic site of Göbekli Tepe in Turkey, dating to approximately 9600 BCE, revealed that hunter-gatherer societies before the development of agriculture were capable of creating massive stone structures requiring significant labor organization and advanced stoneworking techniques. This discovery overturned previous assumptions that such monumental architecture required settled agricultural societies. The Antikythera mechanism, an ancient Greek astronomical calculator dating to approximately 100 BCE, demonstrated a level of mechanical sophistication that was not matched again until medieval Islamic and European clockmaking traditions. The precision and complexity of this device surprised researchers when it was fully analyzed using modern imaging techniques. Ancient Roman concrete used in harbor works and major buildings has proven in some cases to be more durable than modern concrete, incorporating volcanic materials and chemical reactions that researchers are still working to fully understand. These and numerous other examples demonstrate that ancient people sometimes achieved technical sophistication that equals or exceeds what we might expect based on conventional narratives of technological progress. Each of these discoveries initially faced skepticism from scholars who doubted that ancient peoples could have created such sophisticated artifacts or structures. Only when the evidence became overwhelming did the scholarly consensus shift to accept these achievements as genuine. The Buache map might represent a similar case where ancient achievements exceeded conventional expectations, though in this case the achievement would be in the domain of exploration and cartography rather than in architecture or mechanical engineering. The possibility of undiscovered ancient maritime achievements gained some support from the growing recognition that sea levels have changed dramatically during human history, flooding vast areas of formerly habitable coastal land. At the peak of the last ice age, approximately 20,000 years ago, sea levels were approximately 120 meters lower than today. This exposed extensive coastal plains and continental shelf areas that are now underwater. As the ice sheets melted between about 20,000 and 7,000 years ago, sea levels rose progressively, flooding these areas and forcing human populations to retreat inland or adapt to changing coastlines. Some of the most productive and desirable land, with easy access to both terrestrial and marine resources, would have been located in these coastal areas that are now submerged. If sophisticated maritime cultures developed in these regions, their settlements and infrastructure would now be underwater, making them difficult to detect and study. Several submerged archaeological sites have been discovered in recent years, including settlement remains off the coasts of Europe, India, and the Americas dating to various periods when sea levels were lower. These discoveries demonstrate that humans did indeed inhabit and utilize the now submerged coastal areas. Whether any of these cultures achieved the level of maritime sophistication necessary to explore Antarctica remains unknown, but the theoretical possibility cannot be dismissed simply because we have not yet found definitive archaeological evidence. The search for such evidence would require systematic underwater surveys of vast areas of continental shelf using expensive specialized equipment, an undertaking that has barely begun. The psychological and cultural factors that might have motivated ancient peoples to undertake long-distance exploration also deserve consideration. Modern Antarctic expeditions have been motivated by various factors including scientific research, national prestige, commercial interests, and personal ambition. Ancient explorers would have had different motivations, but the human drives toward curiosity, adventure, competition, and the desire to access new resources would have operated then as now. If climate conditions periodically made southern regions more accessible, whether through reduced sea ice, favorable wind patterns, or other factors, some individuals or societies might have been motivated to explore these regions to see what resources or opportunities they offered. Even if sustained colonization of Antarctica was not possible due to its climate, temporary expeditions might have been undertaken for various purposes such as hunting, fishing, obtaining minerals or other resources, or simply for exploration and prestige. The fact that Antarctica's interior is inhospitable does not preclude its coasts and surrounding waters being visited seasonally by hardy maritime peoples, much as Arctic regions have been visited and utilized by indigenous peoples for thousands of years despite their harsh conditions. If such visits occurred regularly over extended periods, detailed geographical knowledge of Antarctic coasts could have accumulated gradually through the observations of many expeditions over many generations. This knowledge could then have been recorded in maps and sailing directions that were eventually transmitted to other cultures and regions through trade, conquest, or cultural exchange. The academic and scholarly response to the Buache map and similar cartographic mysteries has evolved over time as attitudes toward unconventional historical evidence have shifted. In the mid-20th century, when the correspondence between the Buache map and seismic surveys of Antarctica was first recognized, many scholars were intrigued and willing to consider various explanations, including the possibility of ancient advanced knowledge. Books and articles exploring these mysteries found receptive audiences among both scholars and the general public. However, as some of these ideas became associated with fringe theories and pseudoscientific claims, mainstream academic attitudes became more skeptical and dismissive. By the late 20th century, most professional historians and archaeologists avoided discussing these maps except to debunk them, fearing that engaging seriously with such material would damage their scholarly credibility. This created a situation where the maps were primarily discussed by non-academic researchers and enthusiasts, some of whom advanced poorly supported or sensationalistic interpretations that further alienated academic scholars. More recently, there has been some movement toward more nuanced engagement, with some scholars recognizing that dismissing these maps entirely may be throwing away genuine puzzles that deserve serious investigation. The challenge is to find a middle ground between uncritical acceptance of extraordinary claims and reflexive dismissal of anything that challenges conventional narratives. This requires careful evaluation of evidence, acknowledgement of uncertainties, and willingness to follow the evidence wherever it leads while maintaining appropriate skepticism about extraordinary claims. The network of mysterious ancient maps extends well beyond the Buache map to encompass a fascinating collection of cartographic documents that all share the common feature of depicting geographical knowledge that seems to exceed what should have been available at the time of their creation. While each of these maps has been analyzed and debated individually, examining them collectively reveals patterns and connections that may be more significant than any single map in isolation. The Piri Reis map of 1513, already mentioned several times, deserves more detailed examination as it represents perhaps the most extensively studied and documented of these controversial cartographic artifacts. The map was created by the Ottoman admiral and cartographer Piri Reis, whose full name was Ahmed Muhiddin Piri. He was not merely a mapmaker but an accomplished naval commander who participated in numerous military campaigns and was deeply knowledgeable about Mediterranean and Indian Ocean geography. His major work, the Kitab Bariyeh or Book of Navigation, became a standard reference for Ottoman mariners and demonstrated his sophisticated understanding of nautical matters. The map that bears his name was discovered in 1929 during renovations of the Topkapi Palace in Istanbul, where it had apparently resided in the imperial archives for centuries, overlooked and forgotten. The surviving fragment of the Piri Reis map shows portions of the Atlantic Ocean including the western coast of Africa, the eastern coast of South America, and various Atlantic islands. What makes this map particularly interesting is not just its geographical content but the extensive notes that Piri Reis inscribed on the map itself, explaining his sources and methods. These notes, written in Turkish, provide rare insight into the cartographic process and the sources available to an early 16th century mapmaker. Philippe Buache explicitly states that he consulted approximately 20 older source maps in creating his compilation. He mentions maps captured from Spanish sailors, including one map that had belonged to Christopher Columbus himself. He refers to maps from the time of Alexander the Great, though whether he meant this literally or was using Alexander's era as a general reference to ancient times is unclear. He also mentions maps of the Western lands, which he called the New World, indicating that he had access to early Spanish and Portuguese charts showing American geography. The notes reveal that Philippe Buache understood he was working with sources of varying age and reliability, and that he was attempting to synthesize information from different traditions into a coherent whole. This explicit documentation of sources makes the Philippe Buache map particularly valuable for understanding how geographical knowledge was transmitted and compiled in the early modern period. The South American coastline on the Philippe Buache map is depicted with remarkable accuracy considering that the region had been explored by Europeans for only about 20 years when the map was created. The general outline matches modern maps quite well, with recognizable features including the mouth of the Amazon River, the bulge of eastern Brazil, and the configuration of the coast extending south toward the Rio de la Plata. Some of the detail shown on the map suggests that Philippe Buache had access to Portuguese charts created by explorers who had surveyed these coasts more extensively than was publicly known at the time. Portugal maintained tight security over its geographical discoveries, treating maps and sailing directions as state secrets that gave Portuguese navigators advantages over competitors. Despite this secrecy, information clearly leaked or was captured, making its way to other maritime powers including the Ottoman Empire. The accuracy of the South American depiction on the Philippe Buache map demonstrates that by 1513, detailed geographical knowledge of Atlantic coasts had accumulated and was circulating among various Mediterranean and European cartographers through channels we can only partially reconstruct. This established accuracy in depicting recent discoveries lends credibility to the possibility that other portions of the map might also be based on genuine geographical information rather than pure speculation. The most controversial feature of the Philippe Buache map is the landmass extending south from the bottom of South America. This southern coastline has been interpreted by various researchers as representing Patagonia, an imaginary extension of South America, a conventional depiction of Terra Australis, or most controversially, the northern coast of Antarctica. Those who argue for the Antarctica interpretation point to several features that they claim match Antarctic geography. The coastline shown on the map extends westward from the southern tip of South America and then turns southward, which some argue corresponds to the actual configuration of the Antarctic Peninsula as it extends toward South America. The map appears to show mountains and valleys along this southern coast, which researchers claim matches the topography of the Antarctic Peninsula region. Some analysts have attempted to project the Philippe Buache map onto modern globe coordinates and have argued that when properly projected, the southern landmass aligns with Antarctic geography. These claims have been challenged by other researchers who point out that the projection and scale of the Philippe Buache map are ambiguous and that different assumptions about how to project the map lead to different geographical interpretations. Critics note that if the southern landmass is Antarctica, it is positioned too far north and at the wrong angle compared to Antarctica's actual location. They argue that the coastline more likely represents an exaggerated depiction of Patagonia or a conventional representation of Terra Australis rather than showing actual knowledge of Antarctica. The debate over the Piri Reis map intensified in the 1960s following the publication of books by Charles Hapgood, an American historian who argued that ancient maps showed evidence of a lost civilization with advanced geographical knowledge. Hapgood's analysis of the Piri Reis map and other ancient maps was detailed and systematic, involving mathematical analysis of the map's projections and comparisons with modern geographical data. He argued that the Piri Reis map and similar documents were based on source maps created by an unknown advanced civilization that had mapped the Earth in detail at some point in the distant past, possibly during the Late Ice Age. Hapgood proposed that these source maps were created using sophisticated surveying techniques and mathematical projections comparable to modern cartographic methods. His work attracted significant attention and influenced many subsequent discussions of ancient maps. However, mainstream cartographic historians have largely rejected Hapgood's conclusions, arguing that his analysis made questionable assumptions about map projections and that simpler explanations could account for the features he considered anomalous. The debate between Hapgood's supporters and his critics illustrates the broader tensions between conventional and alternative approaches to historical evidence. Hapgood's work was methodical and attempted to use rigorous analytical techniques, yet his conclusions challenged fundamental assumptions about ancient capabilities and were therefore treated with skepticism by most academic scholars. The Orontius-Phineus map of 1531, created by the French mathematician and cartographer Orens Fine, provides another important data point in this cartographic puzzle. Fine was a respected scholar who held the chair of mathematics at the Collège Royal in Paris and who made contributions to mathematics, astronomy, and cartography. His world map of 1531 is executed in a cordiform or heart-shaped projection and shows the continents with considerable detail. The southern portion of the map includes a large continent labeled Terra Australis positioned at the South Pole. This Antarctic continent is shown with considerable geographical detail including mountain ranges, rivers flowing to the coast, and bays and inlets along the coastline. The general outline of the continent bears some resemblance to the actual shape of Antarctica, particularly in showing a roughly circular form with a peninsula extending northward toward South America. Some researchers have argued that specific features on the Orontius-Phineus map correspond to real Antarctic geography. They point to mountain ranges on the map that allegedly match the positions of the Transantarctic Mountains and other Antarctic ranges. They note rivers shown flowing to the coast and argue that these represent Antarctic valleys and glacier as they would appear without ice coverage. They observe that the relative positions of various features appear consistent with actual Antarctic geography when accounting for the limitations of 16th-century map projections. Critics of these interpretations counter that the similarities between the Orontius-Phineus map and actual Antarctic geography are less precise than advocates claim and can be explained as coincidental. They point out that Renaissance world maps commonly included large southern continents based on the classical theory of Terra Australis, and that these continents were typically shown with elaborate geographical details that were entirely invented. The rivers, mountains, and coastal features on the Orontius-Phineus map, according to this interpretation, represent artistic embellishment and conventional cartographic practice rather than genuine geographical knowledge. Critics note that if one compares the Orontius-Phineus map carefully to modern maps of Antarctica, many features do not match. The proportions are wrong in various places, features appear in incorrect locations, and the overall level of detail seems more consistent with artistic invention than with copying from accurate source maps. The debate over this map parallels the debates over the Piri Reis and Buache maps, with proponents arguing for genuine ancient knowledge and skeptics proposing more conventional explanations. As with the other maps, definitive resolution of the debate is difficult because we lack access to the sources that Fine used, assuming he used specific sources rather than creating his Antarctic continent from imagination and convention. The Mercator World Map of 1569 represents yet another significant document in this cartographic tradition. Gerardus Mercator was perhaps the most influential cartographer of the 16th century, and his map projection, which preserves angles and shapes at the cost of distorting areas, remains in use today for navigation. His world map showed Antarctica as a large continent surrounding the South Pole, with considerable detail in coastal outlines and interior features. Mercator labeled various regions of this Antarctic continent with place names, though the origins of these names are unclear and they may represent conventional labels rather than actual geographical information. What makes Mercator's Antarctic depiction interesting is that he was known for his careful evaluation of sources and his attempts to incorporate the most reliable geographical information available. Mercator maintained extensive correspondence with other scholars and cartographers throughout Europe and had access to geographical information from multiple sources. If he believed there was credible information about Antarctic geography available, this lends some weight to the possibility that such information existed in 16th-century sources. However, Mercator was also working within the conventional theoretical framework that assumed the existence of Terra Australis for reasons of symmetry and balance, so his inclusion of Antarctica might reflect theory rather than observation. Distinguishing between these possibilities requires careful analysis of the specific features he depicted and comparison with other contemporary maps. The question of map projections and how they affect our interpretation of ancient maps deserves special attention, as this technical issue is central to many debates about cartographic accuracy. Modern maps use standardized projections with well-defined mathematical properties that allow distances, angles, and areas to be measured accurately. Ancient and medieval maps often used less rigorously defined projections, or in some cases no systematic projection at all, with geographical features positioned based on loose conventions rather than precise mathematical relationships. This makes it challenging to compare ancient maps directly with modern maps, as we must first determine how the ancient map should be projected onto a globe or translated into modern coordinates. Different assumptions about projection can lead to very different interpretations of what an ancient map depicts. Charles Hapgood's analysis of ancient maps devoted considerable attention to this projection question, arguing that some ancient maps appeared to use sophisticated projection systems similar to those developed in the modern era. If true, this would suggest advanced mathematical knowledge in the cultures that created the original maps. Critics argued that Hapgood's projection analyses involved circular reasoning, where he assumed certain projections in order to make the maps fit his hypothesis, rather than deriving the projections independently from the maps themselves. This methodological debate highlights the technical challenges involved in analyzing ancient cartographic materials. Another category of potentially relevant maps includes Portoland charts, the detailed nautical charts used by medieval and Renaissance sailors in the Mediterranean and later in the Atlantic. Portoland charts are characterized by their networks of rhumb lines radiating from compass roses, indicating directions for sailing from one port to another. These charts were working documents used for practical navigation, and they needed to be accurate to be useful. Studies of Portoland charts have revealed that they achieve remarkable accuracy in depicting Mediterranean coastlines and distances, suggesting that they were based on systematic surveying or careful compilation of sailing directions. The origins of the Portoland chart tradition are somewhat mysterious, as the charts appear suddenly in the historical record in the late 13th century without clear precursors. Some researchers have suggested that Portoland charts might have been based on even older sources, possibly going back to Roman or Phoenician times when Mediterranean navigation was highly developed. If Portoland charts preserve ancient geographical knowledge about the Mediterranean, might similar traditions have preserved knowledge about other regions, potentially including Antarctic waters? This is speculative, but it illustrates how the existence of one tradition of transmitted geographical knowledge makes others seem more plausible. The accuracy of Portoland charts demonstrates that detailed geographical information could be preserved and transmitted through generations of chart making, even in the absence of systematic surveying in the modern sense. The role of Arab and Islamic geographical scholarship in preserving and transmitting ancient knowledge provides another important context for understanding how information about Antarctica might have survived from ancient times. During the medieval period, when much of Europe was experiencing reduced scholarly activity, the Islamic world was actively preserving, translating, and expanding upon the geographical and scientific knowledge of ancient Greece, Rome, Persia, and India. Major centers of learning in Baghdad, Cairo, Cordoba, and other cities housed extensive libraries containing manuscripts in multiple languages. Arab geographers produced their own important works, including detailed descriptions of trade routes, climate zones, and the characteristics of different regions. They also created maps, though Islamic cartography used different conventions than European mapping traditions. When European scholars began to rediscover classical learning during the Renaissance, much of this recovery occurred through contact with the Islamic world, particularly in Spain where Christian, Muslim, and Jewish scholars interacted in major translation centers. Geographical texts and maps were among the materials transmitted from Arabic to Latin during this period of cultural exchange. If ancient geographical knowledge about Antarctica had been preserved in Arabic sources, whether from Greek, Roman, or other origins, it could have been transmitted to European scholars during the Renaissance and early modern period. The Piri Reis map demonstrates this transmission process explicitly, as Piri Reis was working within the Ottoman Islamic geographical tradition while also incorporating information from European sources. The question of why accurate geographical knowledge would have been preserved if its origins and context were forgotten relates to the practical value of such information for navigation and trade. Even if the specific circumstances under which maps were originally created became obscure, the maps themselves would retain value as guides for navigation as long as they were reasonably accurate. Sailors and merchants using these maps for practical purposes would have noticed if they were accurate or inaccurate, and they would have corrected obvious errors while preserving information that proved reliable. This practical feedback mechanism would have exerted selective pressure favoring the preservation of accurate geographical information even as the original context of exploration and surveying faded from memory. Over time, the origins of the maps might become legendary or mythological, attributed to ancient sages or mysterious sources, while the geographical content remained grounded in actual observation. This pattern is visible in various traditions of geographical knowledge. For instance, certain accurate information about distant Asian regions was preserved in European geographical texts throughout the Middle Ages, even though the original explorers and travelers who had gathered this information were forgotten and the information itself became mixed with legendary material. When Marco Polo and other medieval travelers finally visited these regions directly, they found that some of the old geographical descriptions were actually quite accurate despite being preserved through centuries of copying and retelling. The technology of medieval and Renaissance mapmaking also influenced what kinds of information could be preserved through copying and transmission. Maps created before the age of printing had to be copied by hand, a labor-intensive process that introduced opportunities for error but also allowed for refinement and correction. A skilled cartographer copying an older map might recognize errors in the source and correct them based on other information available. Conversely, an unskilled copyist might introduce new errors while attempting to reproduce the source faithfully. The result was that maps evolved as they were copied, with geographical understanding gradually improving in some respects while potentially degrading in others. The introduction of woodcut and copperplate printing in the 15th and 16th centuries allowed maps to be reproduced more reliably, but even printed maps went through multiple editions with updates and corrections. The maps we have today from Renaissance cartographers like Pierre Race, Orensfine, and Mercator represent single points in these complex chains of transmission and evolution. Behind each published map lies a history of sources, compilations, corrections, and interpretations that we can only partially reconstruct. Understanding this complex process is essential for evaluating claims about ancient geographical knowledge, as we need to distinguish between features that represent old preserved information and features that were added or modified by later cartographers. The scholarly debate surrounding the Buache map and related cartographic anomalies has generated substantial criticism from mainstream historians and geographers who argue that the apparent correlations between these ancient maps and modern geographical knowledge are either coincidental or have been exaggerated through selective interpretation and wishful thinking. These critics make several important points that must be addressed in any balanced evaluation of the evidence. First, they note that when examining any ancient map that shows a hypothetical or poorly known region, one can almost always find some features that appear to match reality if one looks hard enough and is willing to make generous assumptions about scale, orientation, and projection. The human mind has a well-documented tendency to perceive patterns even in random data, a phenomenon known as pareidolia or apophenia. When researchers are motivated to find ancient knowledge in old maps, they may unconsciously emphasize features that appear to match their hypothesis while downplaying or ignoring features that do not match. This critique is serious and methodologically sound, as confirmation bias is indeed a real problem in research across all disciplines. Responsible evaluation of the Buache map requires acknowledging this risk and attempting to assess the evidence as objectively as possible. Second, critics point out that many Renaissance and early modern maps showing Terra Australis included elaborate geographical details that were clearly invented rather than based on observation. Cartographers of this period often felt obligated to fill in blank spaces on their maps rather than leaving regions unmarked, and they drew upon artistic convention, philosophical theory, and imagination to create plausible-looking geography for unexplored areas. Rivers, mountain ranges, and coastlines were added to make maps look complete and authoritative, even when the cartographer had no actual information about these regions. Given this widespread practice of cartographic invention, skeptics argue that we should assume the Antarctic features on maps like those of Buache, Orontius Phineas, and Pierre Race represent this kind of conventional invention unless we have strong positive evidence to the contrary. The burden of proof, according to this view, lies with those who claim that ancient maps show genuine geographical knowledge rather than with those who propose conventional explanations. This is a reasonable methodological position, as extraordinary claims do require stronger evidence than ordinary claims. However, the question remains whether the specific correlations between the Buache map and modern seismic data are strong enough to meet this evidential burden. Third, critics note that even if we grant that some ancient maps show surprisingly accurate features, this does not necessarily prove the existence of lost civilizations or ancient advanced knowledge. More prosaic explanations might suffice. For instance, ancient and medieval sailors might have ventured farther than historical records indicate, gathering information about distant regions that was incorporated into maps without proper documentation of who explored where and when. The absence of written records of such voyages does not prove they did not occur, particularly given that most human history occurred before writing systems were developed and that even in literate societies, many activities went unrecorded. If we assume that ancient maritime exploration was more extensive than surviving records suggest, we might be able to explain accurate geographical information in old maps without requiring advanced lost civilizations or impossible climate conditions. This explanation is more parsimonious than alternatives invoking lost civilizations, as it requires fewer extraordinary assumptions. However, it still faces the challenge of explaining how ancient sailors could have observed Antarctic features that are currently buried under ice. Unless we allow for either temporarily reduced ice coverage or for improbably advanced exploration capabilities, even this more conservative explanation struggles to account for the Buache map's accuracy. A fourth line of criticism focuses on the precision and specificity of the alleged correlations between ancient maps and modern geography. Skeptics argue that when examined carefully, the matches are less exact than they initially appear. For instance, while the Buache map does show Antarctica divided into two landmasses, the exact position and orientation of the dividing channel does not match modern data precisely. The proportions of the two landmasses are approximately correct but not exactly so. The overall outline of the continent is recognizable but simplified and in some respects incorrect. These imperfections are exactly what we would expect if Buache was working from incomplete or degraded information, but they are also consistent with coincidental approximate matches between speculative geography and reality. Critics argue that if we set the bar for matching low enough, allowing for substantial differences in detail while claiming that general patterns match, we can make almost any map of a roughly circular polar continent appear to match Antarctica. To assess this criticism fairly requires statistical analysis of how likely it is that a map would show the specific combination of features that Buache's map displays. This is methodologically challenging, as it requires defining precisely what features constitute a match and what probability we should assign to each feature appearing by chance. Different researchers using different analytical frameworks have reached different conclusions on this point. Despite these legitimate criticisms, the defenders of the anomalous ancient maps argument make counterpoints that deserve serious consideration. They note that while it is true that some features of ancient maps might match reality by coincidence, the Buache map shows multiple independent features that all correlate with actual Antarctic geography. The probability of multiple independent correlations all occurring by chance is much lower than the probability of any single correlation occurring by chance. To illustrate with a simplified example, if there is a 20% probability that a randomly drawn map would show Antarctica divided into two parts, a 25% probability that it would show the correct relative sizes of these parts, a 30% probability that the dividing channel would be in approximately the right location, and a 25% probability that the overall proportions would be approximately correct, then the probability of all four features occurring together by pure chance would be approximately 0.4%. This remains a rough calculation that makes various assumptions about independence and probability that could be questioned, but it illustrates why multiple correlations are more significant than single correlations. Critics might respond that these probability estimates are too generous or that the features are not truly independent, but the general principle that multiple correlations are harder to explain as coincidence remains valid. Defenders of the ancient maps hypothesis also point out that the practice of inventing geographical details for unknown regions, while certainly common, does not prove that all details on all maps were invented. Some maps might contain genuine information mixed with invented details, and the task for researchers is to distinguish between these two categories. The fact that many Renaissance maps of Terra Australis were largely invented does not prove that all such maps were entirely invented. We need to evaluate each map on its own merits, considering the specific features it displays, the claims made by its creator about sources, and the historical context in which it was produced. The Buache map is unusual in several respects that distinguish it from typical speculative maps of Terra Australis. As noted previously, it shows a modest-sized continent rather than an enormous one. It positions Antarctica at the pole rather than extending into temperate zones, and most distinctively, it shows the continent as divided. These features collectively make it different from conventional speculative depictions, suggesting that Buache may have been working from different sources than those used by other cartographers. The question of what constitutes adequate evidence for extraordinary claims is central to this debate. Science and scholarship operate on the principle that extraordinary claims require extraordinary evidence, a standard famously articulated by Carl Sagan but recognized in various forms throughout the history of rational inquiry. The claim that ancient maps show accurate knowledge of Antarctica is certainly extraordinary, as it challenges conventional understanding of ancient capabilities and of Antarctic climate history. What level of evidence would be required to justify accepting such an extraordinary claim? Different scholars would set this bar at different heights depending on their prior beliefs and their assessment of what is plausible. For some, no amount of correlation between ancient maps and modern geography would suffice without direct archaeological evidence of ancient Antarctic exploration, such as artifacts or structures dating to ancient periods found in Antarctica. For others, sufficiently precise and numerous correlations between maps and geography might be accepted as evidence even in the absence of direct archaeological confirmation, particularly given the difficulty of finding archaeological evidence for ancient maritime activities. This difference in evidential standards reflects deeper philosophical differences about how to weigh different types of evidence and how to balance skepticism against open-mindedness. The role of interdisciplinary research in evaluating these cartographic mysteries deserves emphasis. Properly assessing the Buache map and similar documents requires expertise from multiple fields including cartography, geography, history, archaeology, geology, climatology, and statistics. No single researcher is likely to have deep expertise in all these areas, which means collaborative interdisciplinary work is essential. However, interdisciplinary research faces its own challenges, as scholars from different disciplines may have different methodological standards, different types of evidence they consider reliable, and different background assumptions about what is plausible. Geologists and climatologists can provide information about Antarctic ice history and past climate conditions. Cartographic historians can analyze map projections and the conventions of historical mapmaking. Archaeologists can assess the plausibility of ancient exploration based on known capabilities of ancient cultures. Statisticians can evaluate the probability of coincidental matches between maps and geography. Synthesizing all this expertise into coherent conclusions is challenging but necessary for making progress on these questions. Unfortunately, interdisciplinary work on controversial topics like ancient maps has been limited, as many scholars are reluctant to engage with questions that are seen as fringe or pseudoscientific. This creates a situation where the topic is left primarily to non-academic researchers who may lack the full range of expertise needed for rigorous analysis. Recent technological advances in cartographic analysis and visualization have created new opportunities for studying ancient maps more rigorously. Digital scanning and image processing allow researchers to analyze maps at high resolution, identifying features and patterns that might not be visible to the naked eye. Geographic Information Systems or GIS software enables researchers to overlay ancient maps on modern geographical data, attempting to find optimal fits and measure how well different features align. Statistical analysis can quantify the degree of correlation between map features and real geography, providing objective measures that can supplement subjective assessments. These technological tools have not yet been applied systematically to the full range of controversial ancient maps, but the work that has been done demonstrates both the potential and the limitations of such approaches. Technology can make analysis more precise and objective, but it cannot eliminate the need for interpretation and judgment about what the results mean. Different analysts using the same tools but making different choices about projections, scale, and feature identification can reach different conclusions. Nevertheless, increased use of rigorous analytical methods represents progress compared to purely subjective evaluations of map accuracy. The broader cultural and intellectual context in which debates about ancient maps occur also influences how evidence is interpreted and what conclusions are drawn. The question of lost ancient civilizations and forgotten knowledge has long fascinated both scholars and the general public, spawning a large literature ranging from careful scholarly work to sensationalistic pseudo-history. This creates a challenging environment for serious research on the topic, as any engagement with these questions risks being associated with less rigorous work. Professional scholars understandably worry about their reputations and may avoid topics that are seen as disreputable, even if those topics contain genuine puzzles worth investigating. This dynamic can create a kind of self-censorship where potentially important questions go unexamined because they are seen as intellectually dangerous. Breaking through this pattern requires both serious scholars willing to risk their reputations by engaging with controversial topics and a broader scholarly culture that can distinguish between rigorous inquiry into unconventional questions and uncritical promotion of fringe theories. Some progress in this direction has occurred in recent years, with increased scholarly interest in ancient technologies and capabilities that were previously underestimated. The recognition that Göbekli Tepe represents sophisticated monumental architecture created by hunter-gatherers, for instance, required scholars to revise previous assumptions about what pre-agricultural societies could achieve. Similar openness to revising assumptions might eventually lead to new insights about ancient geographical knowledge. The psychological appeal of mysteries like the Buache map should also be acknowledged, as human beings are naturally drawn to puzzles and unexplained phenomena. The idea that ancient peoples might have possessed knowledge that was later lost touches on deep themes about the rise and fall of civilizations, the fragility of knowledge, and the possibility that history is more complex than we typically assume. These themes resonate across cultures and time periods, appearing in myths and legends about golden ages, lost wisdom, and forgotten lands. The popularity of books and documentaries about ancient mysteries reflects this enduring fascination. While scholarly inquiry should be motivated by pursuit of truth rather than by the desire to find exciting mysteries, we should also recognize that the emotional appeal of these topics is not inherently problematic. Curiosity and wonder are legitimate motivations for research, and many important discoveries have resulted from researchers pursuing questions that initially seemed far-fetched or unlikely. The key is to maintain intellectual rigor and honesty while following one's curiosity, being willing to follow evidence toward conventional conclusions if that is where it leads, while also remaining open to unconventional conclusions if the evidence points in that direction. The question of how new evidence might eventually resolve debate about the Buache map and similar cartographic anomalies deserves consideration. What kinds of discoveries or developments might definitively answer the questions raised by these maps? One possibility would be the discovery of the actual source maps that Buache consulted. If researchers could locate in archives or libraries the specific older maps that Buache used, and if these maps showed similar Antarctic features, it would confirm that Buache was indeed copying from older sources rather than inventing. This would push the question back one step: where did those older sources get their information? But it would at least verify Buache's explicit claim about having consulted ancient sources. Another possibility would be archaeological discoveries in Antarctica itself. If archaeological surveys of ice-free areas in Antarctica, particularly along coasts or in regions where ice coverage has recently retreated, were to discover artifacts or structures indicating human presence in ancient times, this would provide direct evidence that Antarctica was explored before the modern era. Such discoveries would be extraordinary and would require careful authentication to rule out modern contamination or misidentification, but they would potentially resolve many questions about ancient knowledge of Antarctica. The difficulty is that systematic archaeological surveys of Antarctica are extremely challenging due to the continent's harsh conditions and the fact that most potentially interesting areas remain ice-covered. A third possibility involves improved understanding of Antarctic climate history. If geological and climatological research were to establish definitively that parts of Antarctica were ice-free or significantly more accessible during periods when human exploration was possible, this would make ancient mapping of Antarctica more plausible. Conversely, if research definitively established that Antarctica has been completely ice-covered throughout the period of human civilization with no significant variations in accessibility, this would make ancient mapping essentially impossible and would strongly suggest that apparent correlations between ancient maps and Antarctic geography are coincidental. Current scientific understanding suggests the latter scenario is more likely, but climate science continues to refine its understanding of past conditions, and future research might reveal subtleties or variations not currently recognized. Ice core analysis, ocean sediment studies, and computer modeling of past climates all continue to improve, gradually building a more detailed picture of Antarctic history. While major revisions to current understanding seem unlikely, the accumulation of detailed evidence might eventually make certain scenarios clearly more or less plausible than they currently appear. A fourth type of evidence that might prove relevant involves better understanding of ancient maritime capabilities through archaeological discoveries in other parts of the world. If researchers were to discover evidence of more sophisticated ancient navigation and seafaring than is currently recognized, this would make long-distance ancient exploration more plausible. For instance, if well-preserved ancient ships were discovered that showed unexpected capabilities for ocean voyaging, or if additional evidence of ancient transoceanic contact between cultures were established, this would demonstrate that ancient maritime technology was more advanced than conventional models suggest. This would not prove that ancient sailors reached Antarctica, but it would make such voyages seem less impossible. Conversely, continued archaeological research that reinforces current understandings of ancient maritime limitations would make ancient Antarctic exploration seem correspondingly less plausible. The field of maritime archaeology has grown considerably in recent decades, with improved technology for locating and studying shipwrecks and underwater sites. This research continues to refine our understanding of ancient seafaring, and future discoveries might shift the balance of plausibility regarding what ancient sailors could have achieved. The implications of accepting that the Buache map contains genuine ancient knowledge about Antarctica extend far beyond the specific question of this one map to touch on fundamental issues about how we understand human history and the development of civilization. If we grant that ancient peoples, whether during the late Ice Age, the early Holocene, or some other period, possess the capability to explore and accurately map Antarctica, we must reconsider numerous assumptions about technological development, cultural achievement, and the transmission of knowledge across millennia. The conventional narrative of human history describes a generally progressive trajectory from simple hunter-gatherer societies through agricultural settlements to urban civilizations, with technological and organizational capabilities increasing over time. This narrative acknowledges setbacks and periods of decline, such as the collapse of the Roman Empire or the Maya civilization, but maintains that overall, human capabilities have expanded rather than contracted over the long term. Ancient achievements like the Egyptian pyramids, the megalithic structures of prehistoric Europe, or the sophisticated astronomical knowledge of various cultures are incorporated into this narrative by attributing them to the gradual accumulation of knowledge and the organizational capabilities of early states and civilizations. However, evidence of ancient maritime exploration reaching Antarctica would be difficult to fit into this conventional framework, as it would require capabilities that supposedly did not exist until much later periods. The response to this challenge would likely involve one of several theoretical adjustments to our historical understanding. One possibility would be to recognize that technological development in the ancient world was more uneven and specialized than we typically assume, with some cultures achieving high levels of sophistication in particular domains while remaining less developed in others. We already know this pattern occurs, as the examples of Polynesian navigation and other specialized ancient technologies demonstrate. Perhaps some ancient maritime culture achieved extraordinary sophistication in seafaring, navigation, and geographical observation while not developing writing, metallurgy, monumental architecture, or other traits we typically associate with advanced civilizations. Such a culture might have left relatively few archaeological traces, particularly if their settlements were primarily coastal and have since been submerged by rising sea levels. This interpretation would require us to broaden our concept of what constitutes an advanced civilization, recognizing that advancement can occur in narrow domains without necessarily implying overall technological parity with modern societies. It would also require acknowledging that our archaeological and historical record might be biased toward preserving evidence of certain types of cultural achievement while underrepresenting others, particularly those associated with maritime activities and perishable materials. Another possible adjustment would involve reconsidering the climate history of Antarctica and allowing for the possibility of brief warm periods or local ice reductions that made parts of the continent temporarily accessible. This would require challenging current scientific consensus about Antarctic ice sheet stability, which is based on substantial geological evidence but might not capture every detail of past climate variations. Scientists have recognized that climate systems can exhibit abrupt changes and that regional climate patterns can diverge from global averages in ways that are not always fully captured in models or in the geological record. If Antarctica experienced brief warm episodes during which coastal regions became accessible, and if these episodes happened to coincide with periods when capable maritime cultures existed elsewhere in the southern hemisphere, the possibility of Antarctic exploration would become more plausible. This scenario would not require advanced lost civilizations but would require specific coincidences of climate and cultural development. Evaluating the plausibility of this scenario requires detailed understanding of both Antarctic paleoclimate and the capabilities of ancient maritime cultures, making it a truly interdisciplinary question that cannot be answered by any single field of study. A third possible implication involves taking seriously the hypothesis of a lost or forgotten ancient civilization that achieved significant technological and organizational capabilities before declining or being destroyed by catastrophic events. This is the most controversial interpretation and the one most strongly resisted by mainstream scholarship, as it lacks direct archaeological support and seems to require special pleading about why such a civilization would leave so few traces. However, intellectual honesty requires acknowledging that absence of evidence is not conclusive evidence of absence, particularly when we consider how little of the Earth's surface has been systematically surveyed for archaeological remains and how much potential evidence has been destroyed by natural processes, rising sea levels, and subsequent human activities. A civilization that existed 15,000 or 20,000 years ago would have experienced dramatic environmental changes as the Ice Age ended, with sea levels rising more than 120 meters and climate zones shifting dramatically. Coastal settlements where such a civilization would likely have concentrated would now be underwater, and subsequent geological processes would have buried or destroyed much evidence. The fact that we have not found clear archaeological traces of such a civilization does not definitively prove it did not exist, though it certainly makes the hypothesis highly speculative and difficult to test scientifically. Each of these possible implications carries its own set of challenges and would require different types of supporting evidence to be accepted by the scholarly community. The uneven development hypothesis is probably the most compatible with existing archaeological evidence and requires the fewest extraordinary assumptions. However, it still faces the challenge of explaining how ancient maritime cultures could have observed Antarctic features that are currently ice-covered. The climate variation hypothesis addresses this challenge but requires accepting that Antarctic ice conditions varied more dramatically than current models suggest. The lost civilization hypothesis is the most speculative but would most comprehensively explain the evidence if it could be substantiated. The reality might involve some combination of these factors rather than any single explanation. For instance, ancient maritime cultures might have been more sophisticated than we recognize, climate conditions might have been somewhat more variable than standard models suggest, and some geographical knowledge might have been transmitted from earlier periods through mechanisms we do not fully understand. The multiplicity of possible explanations and the difficulty of definitively testing them reflects the fundamental challenge of reconstructing events from the distant past using fragmentary evidence. The institutional and social factors that shape how evidence about ancient achievements is evaluated deserve recognition in any balanced discussion of these issues. Scientific and scholarly communities operate according to established paradigms and methodological standards that serve important functions in maintaining intellectual rigor and avoiding the acceptance of false claims. These standards appropriately require strong evidence for extraordinary claims and favor explanations that fit within existing theoretical frameworks over those that require major revisions to accepted understanding. However, these same institutional mechanisms can also create resistance to genuinely new insights that challenge established views. The history of science includes numerous examples of important discoveries that were initially rejected or ignored because they contradicted prevailing paradigms. Continental drift, meteorite impacts as causes of mass extinctions, and the bacterial origin of stomach ulcers are all examples of ideas that face strong initial resistance from scientific establishments before eventually being accepted based on accumulating evidence. These historical examples suggest that we should be open to the possibility that current consensus views about ancient history and capabilities might require revision if sufficient evidence accumulates, while also maintaining appropriate skepticism about claims that lack adequate support. The question of what motivates different researchers to interpret the Buache map and similar evidence in different ways often involves unstated assumptions and prior beliefs about what is plausible or likely. Researchers who are generally skeptical of unconventional historical claims will tend to interpret ambiguous evidence conservatively, favoring explanations that require fewer revisions to established understanding. Researchers who are more open to challenging conventional narratives may interpret the same ambiguous evidence more liberally, seeing it as potential support for alternative scenarios. These different interpretive tendencies are not simply matters of bias or prejudice but reflect different judgments about how to weigh various types of evidence and how to balance conservatism against openness to new ideas. Understanding these different approaches can help facilitate more productive dialogue between researchers with different perspectives. Rather than dismissing those who interpret evidence differently as either closed-minded skeptics or credulous believers, we can recognize that different individuals may reasonably reach different conclusions when dealing with incomplete and ambiguous evidence. Progress occurs through ongoing dialogue, accumulation of new evidence, and refinement of analytical methods, rather than through any single decisive proof that settles all questions definitively. The role that the Buache map and similar cartographic anomalies play in popular culture and public consciousness also merits consideration, as these maps have captured imaginations far beyond academic circles. Books, documentaries, and online discussions about ancient maps and possible lost civilizations reach millions of people and shape how the broader public thinks about human history and ancient achievements. This popular interest creates both opportunities and challenges for serious scholarship. On the positive side, public fascination with these topics can generate support and funding for research into ancient maritime history, archaeological surveys of submerged coastal sites, and other investigations that might shed light on these questions. Public interest also provides motivation for scholars to engage with these questions and to communicate their findings to non-specialist audiences. On the negative side, the popularity of sensationalistic claims about ancient advanced civilizations and mysterious lost knowledge can make serious scholarly engagement with related topics more difficult, as researchers risk being associated with fringe ideas. The challenge is to maintain high scholarly standards while also engaging constructively with public interest in these topics, neither dismissing genuine puzzles because they have been sensationalized nor accepting extraordinary claims without adequate evidence simply because they are exciting. Educational approaches to teaching about historical cartography and geographical discovery could benefit from incorporating discussion of maps like Buache's as examples of the complexity of historical evidence and the challenges of historical interpretation. Rather than presenting history as a simple accumulation of established facts, students could be encouraged to grapple with ambiguous evidence, consider multiple possible interpretations, and think critically about what types of evidence would be needed to resolve uncertainties. The Buache map provides an excellent case study for such educational purposes because it involves real scholarly debates with substantive arguments on multiple sides, because it requires understanding contributions from multiple disciplines, and because it illustrates how the same evidence can be interpreted differently depending on one's methodological approach and prior assumptions. Engaging students with such complex cases helps develop critical thinking skills and prepares them to deal with the kinds of ambiguous situations they will encounter in professional and civic life. It also provides a more accurate picture of how historical knowledge is actually constructed, as a process of interpretation and argument rather than simple recovery of facts. The future of research on the Buache map and related cartographic puzzles will likely depend on several factors, including the availability of new technologies for analysis, the willingness of scholars from multiple disciplines to collaborate on these questions, and the accumulation of new evidence from various sources. Advances in imaging technology may allow more detailed analysis of old maps, potentially revealing features or information not previously recognized. Improved computer modeling of Antarctic ice sheet history may refine our understanding of when and whether parts of Antarctica might have been more accessible in the past. Archaeological surveys, both in Antarctica and in other regions where ancient maritime cultures existed, may provide new information about ancient seafaring capabilities and the extent of ancient exploration. The digitization of archival collections and the development of better cataloging and search tools may help researchers locate and identify old maps and manuscripts that might shed light on the sources available to cartographers like Buache. Each of these developments has the potential to move debates forward by providing new evidence or new analytical capabilities. The preservation of historical maps and documents is itself an important consideration, as these materials are often fragile and vulnerable to degradation over time. Many important historical maps exist in only single copies or in small numbers of manuscript copies, and some have been damaged or lost over the centuries. Efforts to digitize and preserve these materials serve not only conservation goals but also make maps more accessible to researchers worldwide who might not be able to travel to the specific archives where originals are held. High-resolution digital scans can preserve details that might be lost if physical documents continue to deteriorate, and digital tools allow for types of analysis that would be impossible or impractical with physical documents alone. The global community of scholars, librarians, and archivists working to preserve and make accessible historical cartographic materials contributes essential infrastructure for research into questions like those raised by the Buache map. Without access to these materials, many important questions about historical geography and the transmission of geographical knowledge simply could not be investigated. The philosophical dimensions of debates about ancient knowledge and lost civilizations also deserve attention, as these debates touch on fundamental questions about progress, knowledge, and human potential. The idea that ancient peoples might have possessed significant knowledge that was later lost challenges progressive narratives that see history as a story of continuous improvement and advancement. If knowledge can be lost as well as gained, if civilizations can decline as well as advance, this complicates our understanding of historical change and raises questions about the fragility of human achievements. These are not merely academic questions but have practical implications for how we think about contemporary civilization and its challenges. If ancient societies achieved more than we typically recognize and subsequently lost much of what they had achieved, this might inform how we think about preserving and transmitting knowledge in our own time. The recognition that technological and organizational capabilities are not automatically preserved but must be actively maintained through institutions, education, and cultural practices has relevance for contemporary concerns about resilience and sustainability. While we should be cautious about drawing direct lessons from uncertain historical cases, the broader themes raised by debates about ancient achievements have enduring philosophical and practical significance. The international and cross-cultural dimensions of studying ancient maps and geographical knowledge are also worth noting. Cartographic traditions developed independently in different parts of the world, with Chinese, Islamic, European, and other cultures creating distinctive approaches to representing geographical knowledge. These different traditions eventually influenced each other through trade, conquest, and cultural exchange, creating complex patterns of knowledge transmission that we are still working to fully understand. The Buache map sits at one point in these global networks of geographical knowledge, potentially incorporating information from multiple cultural traditions and time periods. Understanding the map fully requires understanding not just European cartography but also the various traditions that might have contributed to the sources Buache consulted. This global perspective on the history of geographical knowledge is increasingly recognized as important for getting beyond Eurocentric narratives that have sometimes dominated historical scholarship. By examining how knowledge moved between cultures and how different traditions contributed to the gradual accumulation of geographical understanding, we develop richer and more accurate pictures of human intellectual history. The ethical dimensions of research into controversial historical questions also merit brief consideration. When engaging with topics that challenge established scholarly consensus, researchers have responsibilities both to maintain intellectual honesty and rigor and to be mindful of how their work might be used or misinterpreted. Claims about ancient advanced civilizations or lost knowledge have sometimes been appropriated for ideological purposes, used to support nationalist narratives, racial theories, or other problematic agendas. Responsible scholarship requires being alert to these potential misuses while not allowing fear of misappropriation to prevent legitimate inquiry into difficult questions. The solution is not to avoid controversial topics but to address them with appropriate rigor, to be clear about what evidence does and does not support, and to challenge misuses of scholarship when they occur. In the case of the Buache map and related cartographic anomalies, responsible scholarship means acknowledging both the genuine puzzles these maps present and the limitations of our current evidence, avoiding both dismissive skepticism and credulous acceptance of extraordinary claims, and remaining open to revising conclusions as new evidence and arguments emerge. The enduring mystery of the Buache map ultimately resists simple resolution, remaining suspended in a space of uncertainty that challenges our historical understanding while defying definitive proof of any particular interpretation. More than 2.5 centuries after Philippe Buache presented his map to the French Royal Academy of Sciences, and more than 6 decades after seismic surveys revealed the hidden topography beneath Antarctica's ice sheet, we are still grappling with the fundamental question of how an 18th-century cartographer could have depicted geographical features that would remain unknown to modern science until the mid-20th century. This persistence of mystery despite extensive analysis and debate reveals something important about the nature of historical evidence and the limits of our ability to reconstruct the distant past with certainty. Some historical questions may remain permanently ambiguous, not because researchers lack intelligence or diligence but because the evidence that would decisively answer them has been lost, destroyed, or never existed in recoverable form. The Buache map may represent such a question, one where we can identify the puzzle clearly and propose various possible solutions, but where conclusive proof for any single solution remains elusive. The various explanations that have been proposed for the Buache map each carry their own burdens of implausibility, and the challenge lies in determining which explanation requires us to accept the least unlikely scenario. If we dismiss the map's accuracy as pure coincidence, we must accept that Buache somehow randomly chose to depict Antarctica in a way that matches reality in multiple independent respects, despite having no knowledge of actual Antarctic geography and despite this depiction differing from conventional speculative maps of Terra Australis. The probability of such a coincidence is difficult to calculate precisely but appears quite low. If we accept that Buache was working from ancient source maps showing accurate Antarctic geography, we must then explain how those ancient maps were created, which requires either that Antarctica was more accessible at some point when human exploration was possible, or that some ancient culture possessed exploration capabilities far exceeding what archaeological evidence currently suggests. Both scenarios face significant challenges from established scientific understanding of Antarctic climate history and of ancient technological capabilities. If we propose that Buache had access to information about Antarctic structure but that this information came from theoretical deduction or indirect evidence rather than from direct observation, we must explain what theoretical framework or indirect evidence could have led to such accurate conclusions, and why similar reasoning did not produce accurate results for other unknown regions. Each path toward explanation encounters obstacles, yet the map exists as a physical historical artifact whose features demand some accounting. This situation exemplifies a broader challenge in historical and archaeological research where evidence is incomplete and where multiple interpretations remain possible. The appropriate scholarly response to such situations involves several elements. First, we must accurately describe what we do know and what remains uncertain, avoiding the temptation to exaggerate either the strength of evidence for our preferred interpretation or the weaknesses of alternative interpretations. Second, we must remain open to revising our conclusions as new evidence emerges or as new analytical methods become available, recognizing that today's consensus might be overturned by tomorrow's discoveries. Third, we must acknowledge the limitations of our current understanding while continuing to investigate, neither prematurely closing questions that might yet yield to further research nor indefinitely suspending judgment when evidence is sufficient to warrant provisional conclusions. Finding the appropriate balance between these competing imperatives requires judgment and humility about the limits of our knowledge. The question of what the Buache map's source maps might have been, assuming they existed, opens fascinating possibilities for research even if definitive answers remain elusive. If we could trace the chain of transmission that brought Antarctic geographical knowledge from ancient observations to 18th century France, we would gain insights not only into the specific question of Antarctic exploration but into the broader processes by which geographical knowledge was preserved, transmitted, and sometimes lost across centuries and civilizations. We know that such transmission occurred for other regions. Greek and Roman geographical knowledge about Europe, Asia, and Africa was partially preserved through Byzantine and Islamic channels and eventually reintroduced to Western Europe during the Renaissance. In the process, some information was lost, some was corrupted, and some was preserved with remarkable accuracy. The mechanisms of this transmission involved scribes copying manuscripts, scholars translating texts between languages, merchants and diplomats carrying books and maps between regions, and cartographers compiling information from multiple sources. If similar processes operated for Antarctic knowledge, traces of this transmission might survive in archives and libraries, waiting to be discovered by researchers who know what to look for. The fact that such traces have not yet been definitively identified does not prove they do not exist, given that vast quantities of historical documents remain uncatalogued or understudied in collections around the world. The technological and methodological tools available for studying historical maps continue to advance, offering new possibilities for extracting information from old documents. Multispectral imaging can reveal text or features that have faded or been obscured over time. Computer analysis can identify patterns in how maps were constructed that might indicate the mathematical or geometrical methods used by cartographers. Databases of historical maps allow researchers to compare features across multiple documents, identifying similarities and differences that might reveal relationships between maps and point toward common sources. Improvements in dating techniques may eventually allow more precise determination of when particular maps or manuscripts were created, helping to establish chronologies of transmission. Chemical analysis of inks and papers can sometimes identify where and when documents were produced. As these technologies become more sophisticated and more widely applied to historical cartographic materials, they may reveal information about the Buache map and its sources that is not currently apparent. Research infrastructure supporting these investigations continues to improve as libraries and archives digitize their collections and as international collaboration becomes easier through digital communication technologies. The broader context of scientific and historical research into Antarctica continues to evolve, with implications for how we understand the Buache map. Glaciological research refines our understanding of how Antarctic ice sheets have changed over time, potentially identifying periods when accessibility was greater than at present. Archaeological surveys of ice-free areas in Antarctica, though limited, may eventually discover evidence of ancient human presence if such evidence exists. Improvements in dating techniques applied to Antarctic geological samples may resolve uncertainties about past climate conditions. Research into ancient maritime capabilities through archaeological discoveries elsewhere in the world may establish whether ancient cultures could have reached Antarctica given sufficient motivation. Each of these lines of inquiry proceeds independently, driven by different research questions and priorities, but collectively they contribute evidence relevant to evaluating the Buache map mystery. Scientific understanding rarely progresses through single decisive discoveries but rather through gradual accumulation of evidence from multiple sources that collectively shifts the balance of probability toward particular conclusions. The Buache map question may eventually be resolved through such accumulation rather than through any single dramatic discovery. The cultural and intellectual legacy of the Buache map extends beyond the specific historical question it raises to influence broader discussions about ancient achievements and the transmission of knowledge. The map has become emblematic of a category of evidence that suggests ancient peoples may have accomplished more than conventional historical narratives acknowledge. Along with other mysterious artifacts and sites that appear to demonstrate unexpected ancient capabilities, the Buache map feeds into ongoing debates about how we should understand human history and whether our current models adequately capture the full range of ancient achievements. These debates occur not only in academic contexts but in popular culture, where they inspire books, documentaries, and widespread speculation about lost civilizations and forgotten knowledge. While some of this popular interest drifts into unsupported speculation or sensationalism, the underlying fascination with ancient mysteries reflects legitimate curiosity about human origins and capabilities. The challenge for scholars is to engage constructively with this public interest while maintaining rigorous standards of evidence and analysis, neither dismissing genuine puzzles because they have been sensationalized nor endorsing extraordinary claims that lack adequate support. The question of whether geographical knowledge about Antarctica could have survived through oral tradition deserves more detailed consideration than it has typically received in discussions of the Buache map. Scholarly discourse about ancient maps tends to focus on written documents and physical maps as the primary means of preserving and transmitting geographical knowledge, but oral tradition has been demonstrated to be a powerful and accurate means of preserving information across many generations. Indigenous peoples around the world have maintained detailed geographical knowledge, historical narratives, and technical information through oral transmission for thousands of years. Australian Aboriginal oral traditions preserve accurate information about coastal landscapes that existed before sea level rise at the end of the last ice age, more than 10,000 years ago. Polynesian navigational knowledge, transmitted orally through specialized training systems, enabled successful voyages across thousands of kilometers of open ocean. These examples demonstrate that oral tradition can preserve complex and detailed information, including geographical knowledge, with remarkable fidelity across time spans that extend well beyond the invention of writing in most human cultures. If we accept that oral tradition can preserve such information, the question becomes whether geographical knowledge about Antarctica could have been maintained in similar fashion until eventually being recorded in maps that served as sources for later cartographers like Buache. This oral tradition hypothesis faces its own challenges, particularly regarding the mechanisms by which oral geographical knowledge would have been translated into written maps. Oral traditions typically preserve information in the form of narratives, songs, or specialized mnemonic systems that are quite different from the format of a map. Converting geographical knowledge from oral to cartographic form requires someone who understands both the oral tradition and cartographic conventions, and who can perform the cognitive work of translating between these different modes of representing space and place. Such translations have occurred historically, as when European explorers worked with indigenous guides to create maps of regions previously known only through local oral knowledge. However, these translation processes often involve direct contact between the oral tradition bearers and the mapmakers. For oral knowledge about Antarctica to have reached Buache sources would have required a chain of such translations extending over potentially thousands of years and passing through multiple cultural and linguistic boundaries. Each step in this chain would have presented opportunities for information to be lost, corrupted, or misunderstood. The fact that the Buache map appears to preserve accurate large-scale features despite this potentially long transmission chain is remarkable and requires explanation. Perhaps certain types of geographical information, particularly distinctive large-scale features like the division of Antarctica into two landmasses, are particularly robust in transmission because they can be described and remembered more easily than fine details of coastlines or measurements of distances. The psychological and cognitive aspects of how people perceive, remember, and transmit geographical knowledge offer another perspective on these questions. Research in cognitive science and psychology has revealed that human spatial memory and geographical understanding have certain systematic characteristics. People tend to remember distinctive landmarks and features better than undifferentiated terrain. They recall large-scale patterns and relationships more accurately than precise measurements. They organize geographical knowledge hierarchically, with broader regional frameworks containing more detailed local information. These cognitive biases in how geographical knowledge is encoded and remembered might help explain which aspects of ancient geographical knowledge would be most likely to survive transmission across many generations. The division of Antarctica into two distinct regions is exactly the kind of large-scale, distinctive feature that would be cognitively salient and memorable. It provides a clear organizing framework for understanding Antarctic geography, the kind of information that would be preserved even as finer details were forgotten or corrupted. If ancient observers recognized this fundamental division of the continent, whether through direct observation of an ice-free or partially ice-free Antarctica or through some other means, this salient feature would be more likely to survive transmission than would specific details of individual coastlines or interior geography. The relationship between the Buache map and contemporary geographical theory deserves deeper examination than it typically receives in discussions focused primarily on whether the map shows ancient knowledge. Buache was not only a practical cartographer but also a geographical theorist who developed ideas about the structure of continents and ocean basins. His concept of the Earth having a systematic framework or skeleton of mountain ranges and oceanic features influenced how he approached mapmaking. When Buache depicted Antarctica as divided into two landmasses, this was consistent with his theoretical understanding of how continents were structured. He believed that continents and ocean basins were organized according to underlying structural principles that could be understood through systematic study. This raises an interesting question about the relationship between his theoretical framework and his sources. Did his sources describe Antarctica as divided, and did this fit conveniently with his theories? Or did his theories lead him to interpret ambiguous source material in ways that emphasized division and structure? Or did the relationship work both ways, with sources and theory mutually reinforcing each other in shaping his final depiction? Understanding this interaction between empirical sources and theoretical frameworks is important for evaluating the map's significance. If Buache was primarily imposing his theoretical expectations onto ambiguous sources, this would reduce the evidential value of the map's accuracy. If he was primarily transcribing information from sources while his theories provided only secondary interpretive guidance, the map's accuracy becomes more significant as evidence of genuine ancient knowledge. The question of what happened to the source maps that Buache consulted, assuming they existed, points to the broader problem of lost historical documents and the incompleteness of the historical record. Libraries and archives throughout history have been destroyed by war, fire, natural disasters, and simple neglect. The Library of Alexandria, perhaps the most famous example, contained hundreds of thousands of manuscripts, many of them unique copies of works that were completely lost when the library was destroyed. But Alexandria was only one of many major ancient and medieval libraries whose contents have been largely or entirely lost. The libraries of Pergamum, Ctesiphon, Cordoba, and Constantinople all suffered destruction or dispersal at various points, taking with them countless documents whose contents we can now only guess at based on fragmentary references in surviving texts. Even in more recent centuries, major fires have destroyed important archival collections, including portions of the French Royal Archives during the Revolution and the Commune. Individual manuscripts have been lost through accident, theft, or simple failure to preserve them as they deteriorated. The cumulative effect of these losses is that the surviving historical record is a small and probably biased sample of what once existed. Documents that were considered important or valuable were more likely to be preserved and copied, while materials considered less significant might exist in only single copies that were eventually lost. Maps showing strange or controversial geography might have been particularly vulnerable to loss if they were considered unreliable or fanciful by later curators and archivists. This recognition of how incomplete our historical sources are has important implications for evaluating claims about ancient knowledge. When we say that we have no direct evidence for ancient exploration of Antarctica or for ancient maps showing accurate Antarctic geography beyond the maps like Buache that have sparked this debate, we must remember that our statement applies only to the small fraction of ancient and medieval documents that have survived to the present. The absence of evidence in the surviving record does not prove that such evidence never existed, only that it does not survive in accessible form today. This does not mean we should uncritically accept claims about lost ancient knowledge, as we must still base our conclusions primarily on evidence we do have rather than on speculation about evidence we do not have. However, it does mean that we should maintain some epistemic humility about negative claims regarding what ancient peoples did not know or could not have accomplished. The evidentiary base for such negative claims is the absence of evidence in a demonstrably incomplete historical record, which is inherently weaker than positive evidence for what ancient peoples did know and accomplish. The future trajectory of research into the Buache map mystery will likely involve several parallel developments that may eventually converge toward firmer conclusions. continued glaciological and climate research will refine our understanding of Antarctic ice sheet history and past accessibility. Archaeological research, both in Antarctica and in regions where ancient maritime cultures flourished, will continue to reveal information about ancient capabilities and achievements. Historical and archival research may identify documents that shed light on Buache sources or on the broader tradition of geographical knowledge about Antarctica. Improvements in analytical methods for studying old maps may extract new information from the Buache map and related documents. Advances in computer modeling and simulation might allow researchers to evaluate more rigorously the probability of various scenarios explaining the map's features. Each of these research streams proceeds according to its own logic and motivations, but collectively they build toward a more comprehensive understanding of the questions the Buache map raises. It is possible that decades from now, the accumulation of evidence from these various sources will make one explanation clearly more plausible than alternatives. It is also possible that the mystery will remain unresolved, with different researchers continuing to favor different interpretations based on how they weigh various types of evidence and how they assess probabilities of unlikely scenarios. The Buache map stands as a reminder of how much about human history remains uncertain and contested, and of how historical understanding evolves as new evidence and new analytical approaches become available. The map that seemed merely a curious speculation in the 18th century took on new significance when 20th century technology revealed that its depiction of Antarctica matched hidden reality. This transformation from curiosity to mystery illustrates how the meaning and importance of historical evidence can change as our knowledge context evolves. Future discoveries or methodological advances might trigger further transformations in how we understand the map. Perhaps tomorrow's research will reveal conclusive evidence for one or another explanation, finally resolving the puzzle. Or perhaps new information will reframe the question in ways we cannot currently anticipate, revealing that we have been asking the wrong questions or looking for the wrong types of evidence. Historical research rarely reaches final conclusions, instead it continually refines and revises our understanding as new information and new perspectives emerge. The Buache map will likely continue to puzzle and intrigue researchers for generations to come, serving as both a specific mystery to be investigated and a broader reminder of the complexities and uncertainties inherent in reconstructing the past. The broader question of what the existence of the Buache map tells us about the relationship between ancient and modern knowledge deserves reflection as we consider the significance of this cartographic mystery. If the map does indeed preserve ancient knowledge about Antarctica, it demonstrates that the relationship between past and present understanding is more complex than simple narratives of progress would suggest. Knowledge is not automatically or inevitably preserved but can be lost when civilizations decline, when libraries are destroyed, when cultural transmission fails, or when changing economic and social conditions make certain types of knowledge obsolete or undervalued. The recognition that knowledge can be lost as well as gained should inform how contemporary societies think about preserving and transmitting their own accumulated understanding. We should not assume that current knowledge will automatically persist into the future without active efforts to maintain institutions, practices, and technologies of preservation and education. At the same time, we should remain open to the possibility that some ancient knowledge may have been preserved in fragmentary or obscure forms that we have not yet recognized or fully understood. The archive of human knowledge is vast, distributed across cultures and time periods, and incompletely accessible to any individual or generation. Humility about the limits of our current understanding, combined with continued efforts to investigate, preserve, and integrate knowledge from diverse sources, offers the best path forward. the mystery of how Philippe Buache came to draw a map of Antarctica showing it divided into two landmasses, a configuration that would not be confirmed until seismic surveys revealed the continent's hidden topography more than 2 centuries later, remains one of the most intriguing puzzles in the history of cartography. Whether this mystery will ever be fully resolved remains uncertain. What is clear is that the map raises profound questions about ancient capabilities, the transmission of knowledge across time, the completeness of our historical understanding, and the methods by which we evaluate ambiguous evidence. These questions extend beyond the specific case of the Buache map to touch on fundamental issues in how we understand human history and how we construct knowledge about the past. As research continues and as new evidence and new analytical methods become available, our understanding of this mystery will continue to evolve. Perhaps future discoveries will vindicate Buache's claim that he was working from ancient sources that preserved genuine geographical knowledge about Antarctica. Perhaps new evidence will demonstrate that the map's accuracy is coincidental or that it arose through some process we have not yet considered. Or perhaps the mystery will remain permanently unresolved, a puzzle that we can analyze and debate but never definitively solve. Whatever the eventual outcome, the Buache map serves as a powerful reminder that history contains mysteries that challenge our assumptions and that resist easy explanation, and that the pursuit of understanding these mysteries, even when definitive answers remain elusive, enriches our appreciation for the complexity of human achievement and the depths of time.